night here at Ether Cosmology. Every Thursday we do reading and research, and I like to throw this disclaimer on there in the beginning just to let you know that Thursday nights, what we are doing here, this is for us to learn. We have our own goals of learning here, and it's not necessarily about entertaining you or making it as digestible as possible, or if we're going to take a few minutes to fix some highlights or something like that, then we're going to just go ahead and do that live on the spot. Or if we're going to look into something randomly, we're going to do that live on the spot. But the idea is to give you a glimpse into our research process and the way that we investigate things and that we learn. So just before we start reading here, because tonight we're actually going to be reading directly from Hector Monera's paper. So before we get into some possibly quite dense reading, just there's the heads up there. But yeah, let's go ahead and jump in.
Awesome. Yeah, 23 pages of interferometry and periodicities.
Yes, so let me share my screen. All right. So are you guys able to see that all right?
Yes, sir.
Okay.
Looks good.
So we have Hector A. Monera, Daniel Hernandez Deckers, Germain Arenas, and Edgar Alfonso from the Department of Physics at National University in Bogota, Colombia. And the name of the paper here is Observation During 2004 of Periodic Fringe-Shifts in a Adialeiptometric Stationary Michelson-Morley Experiment. Adialeiptometric. I think I had it right.
Dude, you nailed it. I was practicing it earlier because I was going to try and impress you, and you know how I'm committed to pronouncing the P with Ptolemy, right? With Ptolemy. Yeah. I can't work it into Adialeiptometric, so but it definitely needs to be in there. But you did a really good job on it.
I remembered reading the name of it last night, and then as I started reading it just now, I'm like, oh no, there's a word in here. And then okay. Anyways, moving on. So, contents. We won't read the. Wait, is this 87 pages?
No, it's 23 pages. This is taken out of a section of a published thing where it's like you get it.
Oh, okay. Only 23 pages. Cool.
Yeah. For this paper.
So, adialeiptometry means unceasing or continuous measurements. We have carried out continuous measurements with a stationary Michelson-Morley interferometer at our CIF laboratory in Bogota, Colombia for almost 2 years, from the end of 2003 to June 2005. The paper reports the results for year 2004, during which we identified large periodical fringe shifts after correcting the environmental variables. To provide a context for the new experimental results presented in this paper, we start by discussing the meaning of speed of light at the time of Einstein and present next the evidence when available for its constancy. We argue that the evidence provided by the original Michelson-Morley experiment and its repetitions is not as strong as usually believed, thus justifying a new experiment that corrects for the main weaknesses uncovered. The observed periodical variations are consistent with the predicted curves using a constant speed of light in a preferred frame that adds vectorially to the laboratory velocity using Galilean addition. Huh. That's interesting. That's quite a thesis there, buddy.
It's like, how did you work all that in, bud?
Yeah, it's gonna be awesome that's a new one. The solar motion that explains our observations is similar to other modern estimates of solar velocity. Also an interesting claim there. All right. The evidence for a constant speed of light in 1900. To provide a context for the new experimental results presented in this paper, we start by discussing the meaning of speed of light at the time of Einstein and present next the evidence then available for its constancy. Section 2 argues that the evidence provided by the Michelson-Morley experiment and its repetitions is not as strong as usually believed, thus making it reasonable to carry out a new experiment, described in Section 3, that corrects for the main weaknesses uncovered. Section 4 summarizes our main empirical results, and Section 5 closes the paper. Einstein's special theory of relativity is based on two assumptions. the postulate of relativity and the postulate that the speed of light is independent of the state of motion of the observer. E.
Very important.
Yeah, let's go ahead and highlight that. That old observer velocity. The first postulate is a philosophical principle that nearly everybody accepts in one form or another. That, for instance, the principle of Galilean relativity is firmly entrenched in classical mechanics. Contrariwise, the second postulate has empirical nature and constitutes a testable assertion. The obvious testable assertion. Let's go ahead and highlight that too. No, you can't test.
It's like even when it was done in his time, it wasn't constant. But anyway.
The obvious question arises, was there any empirical evidence at the turn of the 20th century for the second postulate? As described in the following, the importance of the negative interpretation of the famous Michelson-Morley, hence fourth experiment is that it constituted the main direct evidence to support the second postulate. On the contrary, any positive result in a Michelson-Morley type experiment would falsify the postulate. Let's call that highlightable. In the spirit of Newtonian mechanics, that was the dominant paradigm in 1900. Let's consider that moment. That motion is relative to a preferred frame of reference. That's what does that mean again?
Sigma.
Sigma.
I think.
Okay.
But it's an integral or the summation or something like that.
Okay.
1 second.
And that is universal in the sense that all observers in the universe may agree on a common scale. Let us determine the speed of light in the laboratory. A photon moves in a straight line defined by the light path itself from a light source at A to a photon detector at B, stationary in the laboratory and located at a distance D measured with rod sticks. If the time of flight from A to B is TAB, the one-way speed of light over the line segment AB is CAB equals D over TAB. The speed defined by equation 1 is, of course, an average over the segment AB, or an average over the segment AB, and thus, it has the familiar meaning of everyday language. For any layperson, it is extremely surprising to realize that the one-way speed of light was unknown during Einstein's lifetime and is still unknown today. Now, you could maybe argue that it's a little bit more understood thanks to the phase conjugate mirrors in Ruyang Wang, but in any case, although various...
you could even argue it with GPS as well.
Oh, yeah, that too. Good point. That's actually what made Ruyang Wang so confident in his phase conjugate mirror experiment.
Yep. Sorry, real quick.
No, go ahead.
That E symbol, that is sigma, capital sigma, and it stands for summations.
Thank you, sir. Sigma. Mm-hmm. Okay, so that would have been the.
So the reference
is relevant to a preferred frame of reference in the summation. So it's just the preferred. Okay. Preferred frame of reference. What it was referring to, I suppose.
It's all good.
When detector B, wait, where was that? Although various suggestions have been measured, though various suggestions to measure the one-way speed of light have been proposed over the years, to our knowledge, no successful experiments with B. So this was actually 2 years before the phase conjugate mirror experiments, interestingly, but also, yeah, GPS kind of does give us an idea.
Yeah, it's hard to argue against GPS when it uses an atomic clock to break a second down to 9,192 millionths of a second.
Yeah. Yeah, but then syncing those clocks to do your... I mean, it's not quite so straightforward, but I would say that Ruyang Wang and Ron Hatch had a few ideas of how you could get real precise about it. Anyways,
yeah.
Although various suggestions to measure the one-way speed of light have been proposed over the years, to our knowledge, no successful experiments with B stationary in the laboratory have been carried out. let alone with B in motion. That is, when detector B moves with respect to the laboratory along the light path. Up to date, there is no empirical evidence indicating whether the one-way speed of light varies or does not. The difficulty to determine the one-way speed of light entirely resides in the measurement TAB, which is the difference between the time at B when the photon arrives and the time at A when the photon is emitted. There are two aspects. Then, on existence of clocks with a resolution high enough to measure the extremely short time intervals involved in a laboratory experiment, and so that was one. And then the other is the difficulty to synchronize the two clocks at A and B. All the classical experiments to determine the speed of light in the laboratory, Fizeau, Foucault, Michelson, have measured C2, the average speed of light along a two-way line from A to B and then back to A, defined by C2 equals 2D over TAB plus TBA, going to 2 over C2 equals 1 over CAB plus 1 over CBA. Table 1 summarizes the values at the beginning of the 20th century for the speed of electromagnetic radiation in free space, according to textbooks. Note, however, that experiments have never been made in free space, whatever it is. The majority of values correspond to the measurement of C2 for light propagating in air in our terrestrial laboratory, which moves with some unknown velocity, Vt, relative to sigma. The speed for light propagating in a vacuum in our terrestrial laboratory is calculated by adding a correction based on the index of refraction in air, which is a function of air density. The latter depends of air composition, mainly humidity, and ambient pressure and temperature at the moment of the measurement. For instance, Michelson based his correction on mean squared pressure and temperature, and added the same correction of 67 kilometers per second to all his speeds in air during the 1924 and 1926 experiments, undoubtedly made under different ambient conditions. By the way, this cavalier procedure to obtain the vacuum speed casts some doubts on the correctness of the small uncertainty of 4 kilometers per second quoted by Michelson for his 1926 experiments, and shown in Table 1. In the experiments of Table 1, the positions of the mirror at B and the detector at A do not change with respect to the laboratory, so that they do not give clues on how the motion of the observer with respect to the laboratory would affect the value of the two-way speed of light. Regarding the motion of the laboratory with respect to the preferred frame, the Earth's orbital speed around the Sun is around 30 kilometers per second, smaller than the uncertainty of 30 to 60 kilometers per second that was attainable by the end of the 19th century, see Table 1. Hence, the measurements available in 1905 for the two-way speed of light could not possibly uncover any effect arising from the orbital motion of the observer. However, if the high resolution of 4 kilometers per second quoted by Michelson in his 1926 experiment is correct, such experimental setup was capable of uncovering the variations in C2 due to the diurnal variation of the projection of Vt along AB arising from rotation of Earth, and due to the annual variation of Vt resulting from the orbital motion of Earth. Ain't that interesting? In an experiment designed with this objective in mind, observations should be made at different times of the day during the whole year, so that the possible diurnal. What's that?
So the I was processing that for a second. So the 1926 experiment. So I've actually never read the Michelson, Peterson, Pete, or whatever it is, the MPP or whatever. I've never read it. So that they're saying that it was capable of uncovering the variations in the speed of light due to Earth's rotation and the difference between the quote-unquote orbit. Is that what they're saying?
Well, yeah, I think this is where Múnera is going to kind of divert from mainstream, right? Because he's basically going to acknowledge periodicity, is what I'm picking up from this.
Yeah, you'd have to. Yeah, okay, because it would be the only thing that could produce it.
So
Okay.
that's why it's like, oh, this guy seems like such a normie mainstreamer, and then all of a sudden he says this, and you're like, wait, what? But yeah, so let's move on here, because he's gonna claim it to be orbital motion, kind of like actually what Marinoff did, really, right?
Yeah, I think he goes on to say it's like I think his end result is like 270 kilometers a second.
Gotcha. So, in an experiment designed with this objective in mind, observations should be made at different times of the day during the whole year so that the possible diurnal and annual periodicities may be identified. I mean, that's a good point as well. Michelson's observations were carried out during the 1926 summer only, so that the effect of velocity could not possibly be observed. Ah, that's an interesting statement. As that's really bizarre, actually.
So,
I don't even know what color to make that. Let's go with yellow.
what's the significance there? Michelson's observations were carried out during the summer so that there would be no effect on velocity. Is that when it would be moving at its most linear or
Dude, I
whatever?
don't even
I,
know. Like
I don't understand I don't understand the implication of what he's getting at.
I think again he's just getting at periodicity. Like, because I get there's like a, what do we say, what Galev showed, there's like a 30% variation, right?
Hmm.
So uh
Saying because it was just one
so because it's
isolated
only one time of
run,
the
there's
year.
nothing.
Yeah.
Okay, gotcha. So yeah, that's actually at the end of the Michelson-Morley paper. They state the 1887 one. They're like, hey, we should definitely run this multiple times a year so we could get more information on it. And they obviously never went ahead with that. Your boy Miller had to pick that up, but yeah, they were aware of that, but they redefined all of physics over it anyway, even before they got the seasonal results for comparison.
Yeah. That's crazy.
They
That
really
w-
jumped the gun, dude. Like if there was like if you were looking at this from a different perspective, right? It's like they got super spooked over this when they could have, they could have been looking at it differently. Like, oh, you know what? We got to do more, average it out. They got one run and we're like, rework it all.
yeah, like he notes it here too. I don't have undo in this. Oh shoot. But yeah, he noted it there that Michelson noted it, or how he wanted to repeat the experiment.
Oh
So,
yeah.
there existed since the end of the 19th century a procedure to determine differences in the two-way speed of light. Indeed, Michelson invented his interferometer in 1881 to compare C2, the two-way speed of light during along arm 1, to C2, the two-way speed of light along arm 2. The interferometer was improved for the 1887 Michelson-Morley experiment. According to Michelson-Morley's negative or null interpretation, they did not observe any difference between C2 and C21 and C22. Hence, they concluded that the two-way speed of light in our moving terrestrial laboratory is constant along any direction. Next, Section 2 discusses whether the Michelson-Morley experiment was properly designed to observe what Michelson-Morley wanted. The relative issue in this section being whether Einstein was aware of the null interpretation of the Michelson-Morley experiment while developing his ideas about the second postulate. Einstein occasionally made the statement that he did not know the results of the Michelson-Morley experiment before 1905. When I asked him how he had learned of the Michelson-Morley experiment, he told me he had become aware of it through the writings of H.A. Lorentz, but only after 1905 had it come to his attention. Otherwise, he said, I would have mentioned it in my paper. Emphasis in the original. This recollection by Einstein is contrary to the most recent documental evidence contained in Einstein's love letters, showing that
Oh, yeah.
Einstein was aware of the Michelson-Morley experiment. Dude, come on.
Dude, it's
Oh,
insane.
good. I'm so glad this is in a published paper. This is awesome.
Yep. Free
This
ammo.
paper's been worth it just for this alone.
Yep.
If nothing else. So
And
okay,
I
so
went and
just
tracked down the sources for these for the love letters too, so I can share those with you as well.
yeah, we should get into that after maybe. I mean
Okay,
that's
I
just
have to.
crazy.
I have to find these letters.
Oh, I'll send them to you.
So
Oh,
he
you
straight
have
up
them?
lied.
Yeah.
That's the
Yeah.
craziest part is the lie.
Oh yeah, dude. Oh, dude, keep reading. It's so egregious.
So he lies and says straight up here that I didn't even know until after I'd come up with my crap, my nonsense. And
Dude,
then I read Lorentz and I'm like, oh, what do you know? I was right.
Oh, what do you know? I was right where I
But
was
don't
looking
look at the
for it.
love letters I wrote. Okay, so indirect knowledge of the Michelson-Morley experiment. Einstein read the work of Lorentz by the end of 1901 and the beginning of 1902 as attested by letter 48 dated in Schaffhausen on the 28th of December 1901 where Einstein writes to Mileva, I want to get down to business now and read what Lorentz and Drude have written about electromagnetic of moving bodies.
Dude, he's got to listen. He's got to study to get his new theory out that is not related to those experimental results in any way.
Dude, it's just a coincidence, right? It's like just ideas are in the air, right? Like he
You
didn't.
know when your brain is like so big that you just see the world in equations. I think
Yeah,
that's what happened.
exactly. So I want to get down to business now and read what Lorentz and Drude have written about electrodynamics of moving bodies. These books were the 1895 Theory of Lorentz and the 1900 Optics book by Drude. The empirical basis for Lorentz's work was the negative interpretation of the Michelson-Morley experiment. Indeed, Lorentz was closely following Michelson's work right from the beginning and sent him a correction to the 1881 experiment. That was acknowledged by Michelson-Morley in the 1887 paper. Evidently, Lorentz continued quite worried about Michelson's negative results, as attested by a letter to Lord Rayleigh on the 18th of August of 1892. Lorentz asked, "Can there be some point in the theory of Mr. Michelson's experiment which has as yet been overlooked?" In addition, Einstein learned about Lorentz's work and its physical basis through Drude's book. The English translation of the book says in the introduction to Chapter 8, the assumption which will be adopted here is that the ether always remain completely at rest. Upon this basis, H.A. Lorentz has developed a complete and elegant theory. It is essentially this theory which is here presented, emphasis in the original. Direct knowledge of the Michelson-Morley experiment. In the same Chapter 8, Drude explicitly discusses the empirical evidence, including Michelson's 1881 experiment in great detail, and the 1887 Michelson-Morley experiment in less detail. From Drude's work, Einstein learned about the constancy of the two-way velocity of light in January of 1902, or you could say geocentrism. But Einstein had previous information on the same subject. In letter 11, dated in Milan around the 28th of September 1899, Einstein says, I read a very interesting paper by Wien from 1898 on this subject. So he had read a paper on it as well as the book. Wien's paper describes 13 experiments related to the detection of the motion of the Earth relative to the ether. The Michelson-Morley, we should grab that. Yeah? We have that?
Oh, yes, we do. Yeah. I bring it up all the time. It's that guy 1888 William Will Wine. What's his name? Win. Anyway, yeah, Win. He lists those experiments, right? So that's the guy that says, hey, of all the experiments that we have to prove heliocentrism, like the orbital velocity, we have stellar aberration, which gives a nice 30 kilometers a second when you ratio that against the 20 arc second. What do you call it? Arc that the stars make in the sky over a year, right? So, but he prefaces that with, "Hey, that's just kinematics, right? We need some substantialness to it." And then he goes on to list all these nulls, right? So among them is Aries, some experiment done with sodium vapor or something like that. I have to look into that because that sounds like a good one. There was the Michelson-Morley ones. Both of those are in there, and there was another one I forget. That was another that's good. But yeah, it's a great paper because he just breaks it down because everyone understood that like, Airy failed to prove the ether. Nah, sure didn't. You know. Everyone got it. Like these were not listed of the proofs of heliocentrism until modern times, where people need to reify it.
Yeah, it sounds like a great place to find someone to steel man it and straw man it,
Mm-hmm.
and then whatever. So the Michelson-Morley experiment is in the list of 10 experiments with negative results. The explicit text is, if the ether is at rest, then the time of a light ray needs to travel back and forth between two glass plates, then the time a light ray needs to travel back and forth between two glass plates must change if the plates are moving with velocity v. The change depends on the quantity v squared times a squared. A is the reciprocal of the speed of light, but should be observable by the application of interferometry. The negative result is incompatible with the assumption of an ether at rest. This assumption can be maintained by means of the hypothesis that the linear dimensions of rigid bodies are altered by motion through the resting ether in the same ratio as to compensate for the lengthening of the path along the light ray. Dude, I still you gotta give Einstein a break. There's just sometimes people just get the same ideas a few years later, you know?
Dude, same ideas with like the same mathematical framework where
the
your
same,
framework even adheres
same
to Lorentz
exact
symmetry.
physical explanation, even.
And then, oh, dude, did you see the Voigt thing? So the Lorentz framework. Hold on, let me pull this up real quick for you. This is crazy. Lorentz, that whole framework came from someone else too. Come on, questions. I keep going. I'll pull it up in a second. Oh, here it is.
Cool.
Nope.
You say keep going, or you got it?
Yeah, keep going. I'm pulling it up.
All right. So,
Come on.
the foregoing new evidence casts serious doubts on the conventional view propounded by Holton that the role of the Michelson-Morley experiment was minor in the genesis of special theory of relativity. It is clear that Einstein knew at least since 1899 that, according to the experimental evidence, the two-way speed of light was independent of direction, and that such a fact necessitated some appropriate physical explanation. Huh. Yeah, that's pretty. I mean, that's like literally first order or first primary sources, like multiple primary sources. So,
Oh, dude, it's insane, bro. So Drew, in his optics book where he was reviewing the Michelson-Morley experiment, he proposes the solution that rigid bodies compress, moving through a stationary ether proportional to their velocity, in the direction of motion. It's like they just like patchwork all this stuff and then took that framework. If you could pull that up on the, well, you don't have to pull it up on the stream because you have to switch back. But yeah, take a look at that in the chat. It's it's like literally the same. It's 1-to-1 Lorentz's framework, and it came out in the 1850s. No, I'm sorry, 1887 derived. So crazy.
oh, okay. Yeah. So. Oh yeah, that's crazy. If anyone wants more information about like that topic of the places where Einstein stole information and the ways he stole information, and just if you want to know about maybe the darker side of Einstein that mainstream doesn't necessarily put out in the open, you should check out Bjerknes's book on the manufacture and sale of St. Einstein, or also go look up, there's a couple of podcast interviews out there of him, I believe, and he kind of does a summary of the book. I've never actually read through the book, but it has like 1,000 pages that are purely citations. It's like a 3,000 or 4,000 page book. But yeah, there's a lot of primary documentation showing the ways in which Einstein was a fraud to put it mildly. So, anyways, this being so, one may be tempted to say with Edwards that the second postulate should be amended to explicitly state that the constancy of light assumed by Einstein refers to two-way speed of light. If that were the case, the second postulate would contain no information about the one-way speed of light. However, given Einstein's concern for economy of thought, it is more likely that Einstein was thinking in his second postulate about the one-way speed of light. In that case, it holds that CAB equals CBA, and equation 2 would immediately imply that the two-way speed is C2 equals CAB. The same for any orientation of the segment AB. In both interpretations, the second postulate may be falsified if the two-way speed of light depends on direction. That is, if a Michelson-Morley experiment yields positive results, notice that to falsify the second postulate, there is no need to measure the one-way speed, thus making moot the conventional stance that it is impossible to measure it.
Oh, wow. Can we get a highlight on that? Because, dudes, I can't tell you how many times, well, it's just with the same person, but he was like, well, the one-way speed can't, like, what? Yeah, they try to hide behind that.
To falsify the second postulate, there is no need to measure the one-way speed, thus making moot the conventionalist stance. Gotcha. Einstein was deeply aware that a positive result in a Michelson-Morley experiment would destroy his theory. Regarding Miller's work, briefly discussed in the next section, Einstein wrote, "The existence of a not trivial positive effect would affect very deeply the fundament of theoretical physics as it is presently accepted." Yeah. Indeed, my man. In retrospect, it is very surprising that Michelson's work regarding the Michelson-Morley experiment was not closely scrutinized in his epoch, especially for the very deep implications it had. It is well known that both Lord Kelvin and Lord Rayleigh urged Michelson to repeat the 1881 experiment, and that in 1900 Kelvin urged Morley and Miller for a repetition of the 1887 Michelson-Morley experiment. The uneasiness of Lorentz is reflected in his 1892 letter to Rayleigh, quoted above. Pardon me. Where'd I go? Quoted above. Towards 1900, there were several minor criticisms to some aspects of the setup of the Michelson-Morley experiment that we have listed elsewhere. But the only significant critical appraisal of the whole process was done by Hicks in 1902. The most disturbing aspect, however, is Miller's claim that the Michelson-Morley experiment was always positive. We turn now to that subject and to two new criticisms that we have recently advanced. Firstly, it must be noted that Michelson-Morley did not obtain a zero shift of the reference fringe as flatly expressed in both relativistic and classical mechanics textbooks without any caveats whatsoever. Rather, they found that the relative velocity of the Earth and the ether is probably less than 1/6 the Earth's orbital velocity, and certainly less than 1/4. Ha! That's one way to look at it, I suppose.
And that's what they say too. They're like, if we're to take these results at face value, then the Earth must be just orbiting hella slow.
Yeah,
I believe,
yeah.
dude. I'm actually I believe in hella slow Earth orbital centrism or whatever. That's my new belief.
Hella slow heliosyndrome.
It's just a slow moving solar system.
That was one of my. If I was gonna try and absorb the Michelson-Morley experiment and Miller and everything, and remain a nihilist, I would say that it's like, yeah, but because of all the relative motion, and when you add it all up all together, it ends up being like that little drift speed or whatever. But it's like still we're doing all those motions.
Yeah.
But yeah, what did you call it, Shane?
Non-slow rotating ether. I don't know. I forget.
You called it helio something, but
Non-slow heliosorcery.
I mean, anyways, so this means that according to their data reduction process, they found a motion of Earth relative to the preferred frame that was certainly less than 7.5 kilometers per second and probably less than 5 kilometers per second. These values, that's a good approach to explaining it, I feel like. When
Wording
it
it that
comes
way.
to the precision of these instruments. Was someone asking a question?
No.
So these values are no doubt smaller than their incorrectly expected 30 kilometers per second, but certainly they were not zero. It is most striking that the 1887 Michelson-Morley paper contains no analysis of the experimental error, which was roughly done for the 1881 experiment. Even the straightforward statistical error analysis is missing. Consequently, there are no error bars in their famous figure, upon which Michelson-Morley based their conclusion quoted in the previous paragraph. Moreover, Figure 6 is obtained from the data listed in 2 tables of the original paper. By an additional reduction process that is unexplained by Michelson-Morley, this weakness in the Michelson-Morley paper went unnoticed until quite recently. We have calculated elsewhere that statistical error associated with the whole reduction process. The very large error bars preempt the conclusions drawn by Michelson-Morley. On the contrary, one may argue that the observations are compatible with Michelson-Morley's original expectation of 30 kilometers per second. Additionally, we also revisited all the original Michelson-Morley type experiments up to 1830, and we found that all of them presented small but non-zero fringe shifts. Oh, is that so? Let's go ahead and highlight.
Additionally, we revisited all the MMX. Okay.
Oh, you want to read that?
No, yeah, I was just recapping it in my head.
Okay.
Yeah, small fringes, but non-zero fringes. Yeah.
So such small fringe shifts were interpreted as negligible by the experimenters, and therefore in support of the special theory of relativity. Miller was the only author that interpreted his results as positive fringe shifts. Can someone else read for a second?
Yeah.
Cool.
Yeah.
Come here, come on.
All right, so Miller,
Shane,
you're hot micing. Miller in citation 22 was the only author that interpreted his results as a positive fringe. So keep in mind real quick, while they were doing the history of interferometry from 1920 or from 1905 to like the 1930s, like he was just saying, they were doing different variations and different orientations and configurations of the Michelson-Morley type right angle interferometers. And what they found was that you could reduce the fringes produced by adjusting things like the arm length, so you can make disproportional arm lengths. You could change the location of the sensor, et cetera, et cetera. You could get varying results with that. So they were all, they all produced different velocities, and some of them trended towards, what they would call zero, like giving a no fringe reading, meaning that there's no velocity difference detected, which is what they would want to get if c is a constant speed. So he's just kind of recapping all of these, and Miller was the only one that interpreted his as a positive result. So because he was, actually looking at the measurement and trying to figure out what he was measuring rather than assuming that what he was measuring was in air and, all that kind of stuff. So Michelson left Cleveland in 1899, and from 1902, his retirement in 1906, Morley teamed up with Miller to repeat the experiments with a more sensitive interferometer, shaving the light paths of 32 meters, about 3 times the path of the 1887 Michelson-Morley apparatus. Observations were made in August 1902, June 1903, consisting of 505 turns of a wood apparatus and with a steel interferometer. In July 1904, 260 turns. In July, October, November 1905, 230 turns. Morley and Miller obtained positive effects between 7 and 10 kilometers, shown in Figure 4, Miller's final paper, citation 22, page 207. Miller also recalculated the original 1887 Michelson-Morley results after applying a linear correction suggested by Hicks for thermal shifts. Citation 25. Can you highlight that? Yeah, we'll have to check that out. I haven't heard of that.
Yeah, I thought that was interesting too.
And obtained a velocity of 8.8 kilometers a second for the noon observations and 8 kilometers for the evening observations. Yeah, that's why it gets so hard to, when you read different papers of people analyzing MMX, you'll get like different velocities. They'll be like, 4 kilometers to 8. So it's like, this is where these different ranges are coming from various analyses, but it's all within that same proximity. So let's see, Michelson. Okay, it may be noted that the Morley-Miller experiments involved 995 turns of the interferometer in the period of 1902 to 1905, while the Michelson-Morley experiment only consisted of 36 turns of the apparatus in the period of June from the 8th to the 12th in 1887. This is quite astonishing that the scientific community accepted the negative interpretation of the latter and rejected the positive interpretation of the Morley-Miller based on 30 times more data. Technology designs. One second, I gotta clear my throat.
Yeah, that's hilarious.
All right. Technological design of the experiment and its environmental control were similar in both cases. Miller resumed alone the interferometer experiments in 1921. During 1921 and 1924, he made observations at Mount Wilson involving 1,181 turns of the interferometer during 1922 and 1924. He took data at Cleveland involving 1,146 turns of the apparatus, and again at Mount Wilson in April 1st, August 1st, September 15, 1925, and those were all done in the year of 1925, and then February 8th of 1926. Miller performed 6,405 turns of the interferometer. Once again, Miller observed positive results between 9.3 and 11.2 kilometers a second, and additionally uncovered an annual periodicity in the variation in the speed of light. So we're looking at, was at the Mount Wilson experiment. So this was the last runs of his career when he's doing them at altitude, after he's honed in everything that he's learned about interferometry and how this device works, how to calibrate it, how to set it up, because your boy was a master at it. So this is where he did his best work. At a station that was designed to, measure the thing that was actually causing the variance, and not trying to remove the variance by imposing restrictions on it.
Well, usually if I'm trying to measure something, I want to get the least fidelity of my measurement that I possibly can.
Yep. By the time that Miller completed his analysis of the data in 1930, Einstein's special theory of relativity was firmly entrenched, and the results were received with great skepticism. Shanklin and his collaborators in citation 28 analyzed Miller's work in 1955, 14 years after Miller died like a bunch of fucking cowards. They acknowledged that Miller's velocity variations were not random, but surprisingly concluded that Miller's periodical changes were caused by thermal, presumably periodic variations. Miller had passed away in 1941 and could not defend himself, but this particular issue was empirically checked by many others by Miller during 1921 and 1924's test. From his test, Miller, Haddle, what is that? Haddle ready?
Haddle?
I'm not familiar with that word.
Me either.
Yeah, Miller, Haddle ready. Had already concluded. Had already concluded that the thermal variations could not possibly have caused the periodic shifts observed. So, not a systemic error that shows the periodicity fluctuation that matches, seasonal, the sidereal time. So, not an error. Let's see where we're at. Okay, from his test, Miller. Yeah. Okay. For furthering arguments in support of Miller's claims to Demio's revision of Miller's work, citation 29. Since the 1900s, there's been a renewed interest in Miller's work. Several authorities independently consider that Miller's results are real and not an experimental artifact. In particular, citations 23, 29, and 35. In particular, Elias 32 and 34 has uncovered new annual periodicities in Miller's data. If Miller's results represent real variations in the speed of light caused by the motion of the laboratory, what is the origin of the small amplitude of the variations? Hence, the small laboratory velocity observed by Michelson-Morley and by Miller. This is the remaining puzzle of history. In our earlier work, the clue has been offered. The Michelson-Morley and the Miller experiments were designed to measure fractions of wavelengths. Larger variations were recalibrated away. To resolve this problem, we analyzed in the next section 2.2 the effect of solar motion upon the readings of any interferometer. For completeness, on any interferometer, that's super. So that's a huge claim, because we've got, ring laser gyre, like any interferometer configuration. So you're saying that these periodicity measurements should be discernible in any interferometer. For completeness,
yeah, crazy.
For completeness, let us note that the vast majority of the physics community does not take seriously Miller's claims. They argue that after 1930, the Michelson-Morley experiment has been repeated many times using modern technology that has always been in accordance with the original experiment outcome that they determined, where they measured a fluctuation but then said that it's pretty much nothing, we don't know what to do, let's redefine all of physics. After only 200 turns or whatever. A precision that is required here, starting with the Kennedy-Thorndike experiment. The data reduction process suffers a change. This is up to this turning point, the Fringe-Shifts analyzed in an effort to detect the variations would lead to a measurement of different velocities of light along the two arms of the interferometer. About the same time, the consensus emerged that the presumably null result of the Michelson-Morley experiment could be interpreted as experimental or empirical proof that the length contraction predicted. Yeah, dude. So sad. For instance, Robertson stated, you scroll down a little bit. Thank you. No significant difference in times was found, and since the original experiment and its repetitions were carried out at various orientations and various times of the year, we would have justified this in interpreting the null result as independence of direction. It is amazing that Robertson completely ignored the 1949. It is amazing that Robertson. Oh, dude, is that Robertson of our boy?
Oh,
Thomas
you're right,
Robertson?
dude. No,
Yeah.
no. It's Roberts. That's Roberts.
Oh, okay. I was gonna say, dude, is that the guy?
So yeah, something.
So yeah, the Kennedy and Thorndike, they had so earlier when I was talking about the different configurations of the interferometer arms, this one was an uneven arm length, and they got a reading of 26 kilometers a second. So they were super close to that elusive 30 kilometers a second, and they went ahead and rounded that down to a 0 kilometer a second. So the speed of light is constant.
I want to scroll down real quick and just check what that is. Who Roberts it is? 38, page 380. 38. H.P.
Postulate
Robertson.
versus
Postulate versus observation. All right.
All right. Okay, let's see. The experiments published in the same journal. Okay, it is amazing that Robertson completely ignored the 1949 and the results of Miller's experiments that were published in the same journal in 1933. The experimental setup of the Kennedy and Thorndike experiment is very similar to the previous Michelson-Morley experiments, except for the length of the arms, which is not the same. But the analysis of the data is quite different. In the Kennedy and Thorndike experiment, it is assumed that the length of the arms of the interferometer are shorter than the physical value. According to Lorentz length contraction, hence dude, no. Like they physically had shorter arms on the interferometer. Anyway, the observed fringe shift, null or otherwise, is then interpreted as a measurement of time dilation with respect to the difference of the apparatus travel time along the shortened arms. Since the observed data are subject to various manipulations during the interpretations of the Kennedy and Thorndike experiment, it is quite difficult to assert that the data reported in the open literature whether a particular Kennedy and Thorndike experiment exhibited fringe shifts relative to absolute space or not. Yeah, they know they can never substantiate it, like that orbital velocity, so they never follow through with it or like commit to it. Like hey, this is the one, this is the configuration that gives us the Copernican principle. They won't do it. They know. And scroll down a little bit. As an example, consider the excellent and often quoted experiment by Brillet and Hall, henceforth, who stated in their paper, our conventional postulate is that space is isotropic represents an idealization of the null experiment of Michelson-Morley. Note that BH talked of an idealization and did not claim that their experiment was exactly the same as the Michelson-Morley experiment. Indeed, a couple of paragraphs below, BH explicitly compared their results to the experiment of the Jezaja and co-workers using infrared masers. Yeah, dude. So these are the dudes that I think one of these did the electron interferometer, and then the other one did the neutrino interferometer. So you get the Brillet Hall, and then the JASA guy.
Interesting. Check that out.
Yep. And then we've got the Brillet one. I think I need to add the JASA one. But we've got the Brillet Hall one. Okay. All right, where are we at?
We're right around here, right?
Yep, looks good to me. The latter belongs to a group of experiments headed by Professor Towns on the isotropy of space, citation 40 to 42. Biederholm and Towns explicitly state the experiment is more closely related to the Kennedy-Thorndike experiment than to the Michelson-Morley experiment. Other contemporary experiment, can you highlight that? Other contemporary experiments either belong to the Kennedy and Thorndike class, so screwed up orientations or have or have built-in corrections whose interpretations are not so clear. Jesus. So they're like, hey, you have two choices of interferometers here. You can use fucked up arms, or you can use one that has built-in corrections to zero out the periodicity.
Yeah,
That's
that's
cool.
crazy.
Science, dude. A recent paper even suggests that the theory behind resonance cavity experiments may be more complicated than expected. Toby, you've got some insights on resonant cavity experiments.
Oh, why
real
don't I
quick.
go publish my paper? Actually, I wonder what we should definitely check that paper out.
Oh, absolutely, because that it'll go in tandem with
Don't
the
get
other
your I
resonance
can go get my
cavity
Nobel
experiment.
Prize.
Yeah. Yeah. So like these
45.
periodicity fluctuations that are measured, so they show up in these resonant cavity measurements as well, and they have to account for that, zero it out with a weighted least squares reduction model, and they basically just pretend like they they're measuring C not being C, and they use that to make it C.
I don't know about this Zotero PDF reader. Okay.
It doesn't seem too bad.
I can't control Z. I think it's because it's trying to control Z to like the main Zotero application.
Disgusting.
Oh. But in any case. Sorry for I just keep wanting to like grab those citations while we're talking about it.
No,
we are right here.
Yep. 2.2 effect of solar motion upon the velocity of the laboratory. The absolute velocity of Earth's center of mass, VT, is the vector addition V sub 0 t in the orbital motion of the center of the mass around the sun is V sub s. The solar system motion, therefore, is equation 3, which is Vt equals Vs plus V0t. Miller used the same conceptual model for his analysis in 1925 to 1926 observations. He even built in a mechanical model. Oh yeah, the old mechanical model.
Yeah.
Of course, the solar motion is very cute. Of the old slowly orbiting Earth. Of course, the solar motion is formed by the velocity with respect to the center of masses of our galaxy, plus the motion of our galaxy with respect to sigma, which is your boy the preferred frame. For the observation periods of a few years relevant to this paper, V sub s is assumed to be constant, and V sub s was the
wasn't it
orbital motion?
The lab frame, I think, wasn't it?
No, you scrolled right by it. It was just right up there.
Oh, just right up there. My bad.
You're good. Yeah, right there. It was plus V sub s, the motion. So the motion of the solar system is supposed to be constant. They're saying so that's not supposed to add any periodicity apparently, or I guess that's what they're getting at. Okay, so the solar system is assumed to be constant with respect to the preferred frame, right? Probably. Okay. For the calculations, let's adopt a celestial equator or equatorial coordinates. See any book on practical astronomy, 46 to 47, with celestial equator contained in the zx plane of the celestial northern pole along the y-axis. To calculate the orbital velocity v sub 0 t, the following approximate model is used. 1. The Earth moves circularly on a plane of the ecliptic. 2. The orbital period is 365.25 days. 3. The tangential speed v sub 0 is 28.9 kilometers a second. 4. The origin of time is noon. The origin of time is noon of March 21 every leap year. It assumes that at t equals 0, an observer at G on the equator latitude lambda equals 0 at the Greenwich meridian, longitude phi equals 0, sees the z-axis. I think if you scroll up, there was a diagram of it.
Interesting. Real quick, just here's the that old
Nice. That old model.
yeah,
Or that old mechanical model.
that old mechanical model.
Dude, some say they're still using that mechanical model to this day.
Yeah, that's from NASA has to make corrections going back to this.
Awesome.
All right, so over here.
All right, so the observer at G rotates counterclockwise on the Z plane with a period T equals 365.25 divided by 366.25 equals 0.99727 solar days. At any arbitrary time T in the solar days, observer G has rotated through the azimuth angle sigma relative to the Z-axis given by sigma equals 360 degrees mod T comma T. Not sure what that's supposed to.
Not sure either.
The angle sigma is shown in figure 1 and is a good proxy for sidereal time. Can you scroll real quick? I want to see where they put sigma in that. Is it in that top?
Oh, right here.
Yeah, right there. Okay, so yeah.
Right here.
So your local meridian, your Greenwich meridian. Okay. Okay, yeah. So the angle produced by that is a good proxy for sidereal time. Okay. As an aid to reckon daily fringe shifts, the number of days elapsed until the first day of each month since the beginning of the 4-year cycle, starting in March 21, 2000, is included in Annex 1. As usual, the local civil time T prime, or no T, whatever.
Star? Oh.
In solar, T star in solar hours may be converted to universal time T, also in solar hours. All right. By using T equals T star minus 24 phi time zone divided by 360, where phi time zone is the nominal longitude for the international time zone, positive, negative to the west or to the east-west of the Greenwich meridian. For calculations used in this paper, phi time zone equals 75 minus 75 degrees for Bogota, Colombia, and Cleveland, Ohio, and the phi time zone equals 100 or minus 120 degrees for the Mount Wilson, California. In the spherical coordinates associated with the equatorial celestial coordinates and shown in figure 2, solar velocity v sub s is described by the magnitude of v sub s, right ascension angle sigma, and the declination angle delta, so that, yeah, all right, so equation 6. All right, we'll look at here. So figure 2, scroll up a little bit. Yeah, let's see what okay. Figure 2, the Earth moves on a circular orbit with the speed of v sub 0 on the plane of the ecliptic defined as zx, okay, axis. The equatorial system of the axis is xyz. The rotated through an angle of epsilon. With respect to the ecliptic, the directions of z and ze axis coincide. At left, the solar velocity v sub s in the spherical coordinates v sub s, sigma, and delta, and the equatorial system of coordinates. Okay. Calculate the orbital motion of the Earth around the Sun. Ecliptic coordinates are used with the plane of the ecliptic contained in the ze and xe plane. The ze axis has the same orientation as the equatorial z-axis towards the first point of Aries at figure 2. At t sub 0, at t equals 0, the orbital velocity of Earth is v sub e, t equals 0 equals minus v sub I e. All right. Since the motion of the Earth is counterclockwise, at any time t, the orbital velocity of the ecliptic coordinates is given by equation 7, where I sub e, j sub e, and k sub e are unit vectors along the xe and ye and ze axis, and the angular orbital speed is omega 0 equals 2 pi radians over 365.25 solar days. The inclination of the plane of the ecliptic relative to t sub 0 of the equatorial coordinates is epsilon equals 23.44, so the orbital velocity t sub 0 t in celestial equatorial coordinates is obtained by the rotating system around the ze axis to get equation 8, where r sub epsilon is the rotation matrix of the ecliptic to equatorial coordinates. See table 2. In equatorial coordinates, the velocity of Earth is given by equation 9. The rotation of the Earth around her axis does not contribute to the course, or does not contribute. Of course, the velocity of her center of mass relative to sigma and the contribution of Earth's rotational velocity to the total speed of the laboratory on the surface is certainly negligible. However, Earth's rotational motion has an extremely significant effect on the magnitude of direction of the projection of the VT on the plane of the interferometer. Let's see. All right, that has been often overlooked with otherwise investigators. Consider a laboratory located on the surface of the Earth at latitude lambda positive north of the equator, the longitude pi positive east of Greenwich, and let the measurement be performed at local civil time t star in hours at t star. The plane defined by the local meridian of the axis of rotation of Earth makes the angle rho with the plane defined by the zy equatorial axis, where we get equation 10. I'll go ahead and read that one since that's a quickie. So rho equals sigma plus phi. The rotation coordinates r sub rho are around the y-axis, although rho aligns with the z-axis and with the local meridians. A further rotation of the coordinates r sub lambda around the x-axis through the angles lambda directs the z-axis towards the local zenith. In this way, the local horizon system of Cartesian coordinates is obtained with the x-axis oriented to the local east e, and the y-axis orientated to the local north n, and the z-axis orientated to the zenith u up. U equals up. All right.
Like that. U equals up. Which all variables could be like that.
Dude, if only it were that easy, right? All right. The local horizon coordinate. So, one second. I want to go back. Or can you scroll down to the bottom before it comes back up? So, there was something.
Yeah, I wanted to highlight this, actually.
Yep. Yeah, so the rotation of the Earth around her axis does not contribute, of course, to the velocity and her center of mass relative to sigma. So, no. So they're saying like that wouldn't even be enough to impact what they're measuring then?
Come on.
For the orbital velocity?
Come on. Nah.
It'd be negligible. Spin. Dude, Earth ball goes spin, but okay.
Don't you know about the Earth's orbital periodicity? Or the Earth's rotational periodicity, I mean? It spins faster in the winter.
Oh my god, dude. Yeah, that's right.
That's just because of the hydrodynamics or whatever?
I forgot about that, because it sounds like he's trying to zero out Earth rotation after it's at this point, and the contribution to Earth's rotation velocity due to the total speed of the laboratory on the surface of the Earth is certainly negligible. So yeah, there's no periodicity attributed to the 3,000 kilometers a second yearly fluctuation, right? It's strictly due to the orbital component that's never measured in full. Okay, cool.
Yeah, that's a crazy paper.
Just wanted to do it's like the hurdles you have to do to like stay on track to be a mainstream heliocentrist lad it's fascinating.
Yeah.
But I respect it.
I don't.
You don't?
Not,
You
no,
don't?
Nope.
Wow.
Yeah.
What do you respect, Shane?
The opposite of that, in fact.
Nice. All right.
I think we're here, right?
Sounds about.
Or no, we
I
read
think
you
we're,
up.
We're a little lower. Yep.
Here.
So in local horizon coordinates, the absolute velocity of the center of mass is given by equation 11, where E is the unit vector along each direction, and the rotation matrices R sub lambda and R sub rho are defined in table 2. Substituting equation 9 and into equation 11, we explicitly get equation 12, where the absolute velocity of the solar system is not known with certainty. On the contrary, the experiment reported to this paper could be used to obtain this value.
Yep. Yep, that's how we figure that stuff out. Just, some second order abstractions. You don't need to verify anything.
It's like, dude, the absolute velocity isn't known with certain, but this paper could be used to do it. Table 3 presents the value of the solar velocity used by Michelson in the design of his experiment in 1881 and 1887. Items 1 and 2. Items 3 and 4 are the two values derived by Miller from his observations in the 1920s. Item 5 is the solar velocity obtained by Marinov in the late 70s.
Our boy.
Shout out to your boy. He had a really unfortunate accident with a library window.
Dude. The homies.
Peace be upon him, man. So, yeah. Let's see. In late 1970s, the experiment with two rotating coupled interferometers. Oh, dude, was that his $500 washing machine?
That's the one. That's the washing machine motor. Yeah, the rotating couplers.
Dude, the washing machine interferometer, dog.
I assure you, what I could do with a weekend and $500, you guys at the International Engineering Committee can come up with something, or is the American National? It was like the National Engineers of America or some crap like that.
Dude, he challenged like the U.S. Navy to reproduce his work, and they were like, "We don't have the money to do that.
We don't have the money or resources." And he's like, "I did it in a weekend with $500 and a washing machine motor. I think you guys can handle it."
Yep. Crazy, dude. Finally, in item 6 is the velocity of Earth relative to the background radiation obtained by means other than interferometric experiments. Citation 49. Can we? Yeah.
Let's see what that is. So we're on page number 7.
Oh, your boy Schmoot and Gorenstein.
You familiar with this one?
I think they're the lads that measured the CMB originally, if I'm not mistaken. But I don't know how they extrapolated a velocity component out of that. But anyway.
All right, so yeah, back to page 7.
For the two scenarios above, figure 3 represents the variation in terrestrial motion from Cleveland, Ohio. Phi equals 81 degrees minus 39 arc minutes. West, lambda equals 41 degrees minus 30 minutes north. During during 8 July 1887, which was the first day of the Michelson-Morley experiment, it may be seen that at the time of the experiment, noon and 6 p.m., the speeds towards the east were much larger than the 30 kilometers a second. Incorrectly expected by Michelson-Morley that the speed towards the north was not zero, as incorrectly expected by Michelson-Morley. What? It may be seen that at the time of the experiment, noon and 6 p.m., the speeds towards the east was much larger than 30 kilometers a second. What? I've
Dude,
never
is he
heard
just
of that.
going? Is he just jumping straight to galactic measurements here?
Well, like, I don't even know what he's talking about.
Dude, I think he's jumping. I think he's just jumping, man. He's just making the. He stepped into the wardrobe.
Yeah, he is. I think is he comparing like his analysis to
Yeah,
the measure? Like,
yeah. He's jumping right into the wardrobe. This guy's a little bit nuts, man. I respect him because he's bucking the system, but he's a little nuts.
Jump straight into it. Okay, so these two facts immediately imply that the Michelson-Morley experiment was incorrectly designed. This is a novel and deep failure of the Michelson-Morley experiment that was recently recognized.
Incorrectly designed. Oh, wait, where did you just read that at?
Right here. At the
Oh,
bottom,
you're
same
at the
spot.
bottom. My bad. This is a deep in reason. I figured it out. Me, dude. It's just like every freaking random kook on YouTube that's gonna pops on and says, "I figured it out. They were all wrong. I have the math."
Can you scroll up a little bit so we could look at the velocity components?
Yeah, let's take a peeky here.
So here we go. We got 1881 Michelson-Morley. Let's see, their velocity component was 30 kilometers a second. Sigma, 18 hours. Delta, so that was their... Michelson-Morley, 18. Solar speed ignored. Okay. Velocity component 0. Miller, 200 kilometers a second. Oh, yeah, with the final adjustments. Miller, 208 with the final adjustments. Marinov, 303 plus or minus 20. And then SGM, which is the cosmic microwave, was Smootin' the boys with the cosmic microwave background, coming in hot with 390 plus or minus 60 kilometers a second.
Interesting.
Yep. So so it's all good. All right,
You
let's
want me
take
to
a
stay
look
up
at
here real quick?
What's that?
No.
No, I was gonna say it's like they got all these different extrapolations for it, but it's fairly simple, man. Like the equation that Ruyang Wang used, like the generalized Sagnac equation, predicts the same. It's the same thing that they use for Michelson-Morley, like the same output gives you the actual velocity component, right? It's how they use, it's how they determine velocity with inertial navigation systems with ring laser gyros. And this dude's just like, nah, I got a whole new system, boys. We're just gonna look at it differently. And it's like, why does he have the freedom to do that? Well, they tell people that these interferometers measure two different things. Like one can't measure linear motion, and another one measures angular rotation. So they're looking at, so he's like applying all this stuff to the one that they say that they can't do anything with to try and make it look better. Is essentially what's happening. And it's crazy that like you can get all those orbital velocities out of that, but none of them can be substantiated or repeated, because if they were to be, right, if those velocity components did exist, they would be reflected in GPS. That's what I really like about GPS now, is that all of these velocities, if they existed, would be reflected in the clock corrections. So.
Well, yeah, and just like you said initially, like just in the Fringe-Shift, like.
Yeah, just how you read it. It tells you what it is. It's not, you can't just make it something else, or like it's hell of an effort, but
Well, it's like the, it's exactly like that thought experiment of, well, I could make a rule that makes 1 plus or 2 plus 2 not actually equal 4, right? Like I could come up with some kind of mathematical rule to do that. You could like extrapolate, and you could do like an abstraction, but then you're gonna lose your predictive value in most cases when you do that. But yeah.
Yeah. All right. So, excuse me one sec.
If you want me to take back over too, I can.
Yeah, if you want to tap in real quick. Oh,
Sure.
or popcorn Toby.
There we go. So did we just read just this here, right?
We were about to read that.
Oh, okay. So figure 3. Components of terrestrial motion in Cleveland, Ohio, as on the 8th of July, 1887. The first day of the Michelson-Morley experiment for 2 scenarios of solar motion. In Table 3, see the text. Item 4 equals Miller 2, and Item 6 equals SGM. What are those dudes called? These guys. The Cartesian...
Smoot and the boys.
Smoot and the boys. That's what SGM stands for, Smoot and the boys. The Cartesian components of the velocity of the laboratory present large diurnal variations whose shape depends of solar velocity. That's, I mean, like, dude.
Wait a minute.
Just cool story, bro. Cool frickin' neato story.
Dude, Toby, sometimes the Earth just rotates a little faster on the... Because it's fire on the bottom.
Because of where it is relative to the sun.
Dude, yeah, it has extra angular momentum based on seasonal variations, bro.
Yeah, let's just make it real clear that if you're absorbing this guy's points of view, like, I respect you because you're probably using your brain a bit more than the standard relativist, but you are definitely not lining up with relativity. You're going against the system. And if you're kind of just jumping, you're like stepping over reality. You're jumping from one nonsensical framework to another just so you can, I don't know, avoid reality, I guess. Like, this is all just simple. This all actually is simple to explain when you don't. This is nonsense. This is silliness. I was trying to zoom in,
Dude,
but
he's like... Dude, you can see him setting up for it earlier in the paper real quick. He was like, the old orbital velocity or the old rotation isn't really going to affect anything, and it's all going to be that velocity component or from the orbital stuff.
you just extrapolate it out into some Cartesian components, and then you take that and slap it onto the velocity of the laboratory frame. There you go. You got your diurnal variations, and what do you know? Earth's moving. Bim, bam, bada bim, bada boom, or whatever, right? There you go. Done. Done. Hands wash.
Just added a bunch of velocity to the lab frame. Nice.
After being on notice for more than 120 years, this subject is expounded in the next section, 2.3. Figure 3 also shows that at noon and 6 p.m., the magnitude of each speed is rapidly varying. Oh, dude, obviously it's just, Earth motion. Obviously. Hence, during the duration of a session of the Michelson-Morley experiment, say between 30 and 60 minutes, there is a significant change on the eastern and northern components of speed. You told us to read this paper, Grayson? This immediately...
Sorry, I need to reread that. Hence, during the duration of a session of the Michelson-Morley experiment, say between 30 and 60 minutes, there is a significant change in the eastern and northern components of... Okay.
This immediately implies that the Earth spins at different speeds at different times of the day. Sometimes when the Earth is moving around the sun, that is also translated into this speed. I'm just kidding. This immediately...
I was rereading that over and over like, what?
Sorry. So, this immediately implies that the initial fringe shift at position 0 is not the same as the final fringe shift at position 16 to the 5th power. Despite, as pointed out so well by Stone, always know we're getting into good, reliable mathematics when we're going to the 5th power. Despite the fact that at both positions, the apparatus has the same orientation with respect to the laboratory. This additional fringe shift at position 16 is a cumulative process that steadily grows the 6 turns of the Michelson-Morley interferometer. The overall result is the monotonous drift present in Michelson-Morley data, which did not merit any comment from Michelson-Morley, but was recognized by Hicks, who ascribed it to thermal effects. On the contrary, in our opinion...
Dude. Sorry. So this is the guy that gave Miller the thermal thing to reduce his periodicity. I didn't know that there was one in Michelson-Morley, and then that this Hicks guy pointed that out. Can you pull up citation 25 real quick?
Yes.
It's like, did they just make a coefficient to zero out the fucking periodicity? They're like, who's the periodicity? I've never heard of that. On the Michelson-Morley experiment relating to the drifts of the ether.
Yeah. Yeah, that would be an interesting one to look at. Where were we?
Up a little bit.
Here we go. On the contrary... Oh, whoops, daisy. On the contrary, in our opinion, the change in the position of the reference fringe at position 16 is the signature of absolute motion, which accounts at least partially for the observed monotonic drift. The Michelson-Morley experiment was designed in the context of Maxwell's theory. Bold statement. For our purposes, the basic assumption is that the speed of light is constant at c with respect to the preferred frame, sigma, independently of the direction of propagation and the velocity of the emitter. Regarding the latter, there exist alternative theories where the motion of the source affects the speed of light. That's citation 50. So we're on page 8. I want to go look at this.
Yeah. Oh, nice. Some French for you to translate.
Ooh, yeah. It was... You know I love reading through and hand translating those French papers.
Electrodynamique, right?
Research critique sur l'électrodynamique générale.
Oh, shit. Where'd Toby go? There's a Frenchman here.
The basic assumption is that the speed of light is constant. Today, so citation 50. The evidence in favor of independence of c with respect to the motion of the source has been provided by astronomical observations. For instance, de Sitter observation of twin stars, and by laboratory experiments. For revision of evidence, for the time being, we simply assume that c is independent of the motion of the source. Also, from the isotropy assumption, it follows that c may be interpreted as a one-way velocity. For an observer at rest in sigma, what was the preferred absolute frame, right?
Yep.
The two-way velocity, equation 2, has exactly the same value c. An observer in motion with respect to sigma will measure a different speed according to Galilean velocity addition. In a Michelson interferometer, light propagates along two different directions, arms 1 and 2, orthogonal to each other. For an apparatus on the surface of Earth, the time-dependent components of the terrestrial velocity, VE, VN, V up, define the response of the interferometer. For instance, a vertical stationary interferometer with one arm oriented along the west-east axis and another perpendicular to the local horizontal plane is controlled by VE and VU. More relevant to the analysis in this paper is a stationary horizontal interferometer with arm 1 oriented from west to east and arm 2 oriented from north to south, where our components VE and VN control the operation of the apparatus. Consider a stationary interferometer with L1, the length of arm 1 oriented west-east, and L2, the length of arm 2 oriented south-north, and let TJ be the two-way time of transit of a light ray along arm J equals 1, 2 of the interferometer. Then, the difference in the time of transit as given by the time delay of the light signal is this, where that. Equation 13, equation 14. And the projection of the Earth's absolute velocity upon the plane of the interferometer V1T given by... I need to step away for 1 minute. Be right back.
Yep. Gotcha. Given by equation 15 and given by equation 16. And if we look at equation 13, it is also applicable to asymmetric interferometers with different arm lengths. The equation may also be used for air analysis if the interferometer arms are identical and at VI or V sub I is small, then equation 13 reduces to equation 17. If the rotating interferometer, or if in a rotating interferometer, equation 17 becomes a new thing, and that's all the space I have to read. Oh wait, I can pull it up on my. Hold on. Am I about to clutch real quick? Where are we at? Page 8. What am I looking for? Reduces to. All right, reduces to equation 17. In a rotating interferometer, equation 17 becomes equation 18, where theta is the angle between the arm 1 and the west-east axis, the conventional expression used by Michelson-Morley for the interpretation of their experiment. In a particular case of equation 18, with V sub n equals 0 and gamma equals 0. From figures 3, one second. From figures 3 and 4, the latter condition is utterly wrong. As noted at the end of the previous section 2.2 in the previous paper 23, the leading author has already discussed the systemic error in the analysis of the Michelson-Morley type experiments. As usual, the fringe shift F is proportional to the time delay so that in the Michelson-Morley rotating interferometer, equation 19, where V and lambda are the frequency and the wavelength of light used in the interferometer, as shown in figure 4, calculated for 8 July 1887 with the same solar velocities used in figure 3, both V1 and gamma depend on the time of day and epoch within a year. For the Miller solar velocity, VI or V sub I at noon and 6 p.m. respectively are 197 and 122 kilometers, whereas for Smoot and the boys, the solar velocity, these values are 303. I'm sorry. What is it? 330 and 248 kilometers a second. All of them are much larger than the 30 kilometers a second used by Michelson-Morley to calculate their expectations. You back?
Those guys that were actually relying on first order, dude. What a dweeb, man. The guy's such a slime ball. He up here he was calling out Maxwell crap. Like, what was he? Oh no, he was saying that they were using Maxwell's theory. So okay, as long as he's not going to try and say he's operating within Maxwell's theory, like, get out of here with your nonsense. So we're here, right?
Close to that, I think. No, a little further down. Let's see.
Oh yeah, right here, right?
Right there. Yep.
You want me to take over?
Yeah, sure.
Cool. So Michelson and Morley compared the fringe shift for phi equals 0 with the fringe shift for, or it's not phi. That is which one is that again? Theta.
Yep.
Theta equals 90 degrees. So equation 20, table 4 shows the absolute value of fringe shift delta F to be expected in a Michelson-Morley experiment for the various scenarios of solar velocity in table 3. In general, fringe shifts of several wavelengths are to be expected rather than the small 0.4 fringe shift predicted by Michelson-Morley. Notice also the strong dependence of the time of day. However, as is well known, the Michelson... Yeah.
I'm sorry, bro. This is how to
hilarious.
turn daily fucking sidereal periodicity into galactic motion, dog.
Dude, don't you know that the Earth moves differently through the speed of the galaxy? It's all relative into this magical equation where I think even when you walk down the street, actually, you just don't realize it, but you just you account for it without even realizing. It's just so minor. It's there, but when you walk down the street, you're accounting for galactic motion.
Man,
And that changes throughout the day.
Look at what it takes to get to galactic motion, dude. To make these measurements that more fit sidereal time with daily fluctuations, right? To make it fit the galactic scale. Look at what they had to do, dude. They had to say that the Earth. They had to come up with a way to describe it where you could zero out Earth rotation as a cause at all, right? And then attribute all the effects to that, but then fit it in the same time zone as Earth rotation.
Yeah,
Okay,
no,
dude.
It's all good, man.
Thanks, Múnera. I see why everyone ignored your fucking paper, dude.
It's like, no, you don't like Múnera, I think you're trying a little too hard to explain things, bud. We like to keep things really, really obtuse. We don't explain things around here when it comes to relativity, because then we usually get in trouble. So, where are we right here, right?
Yeah.
So, however, as well known, the Michelson-Morley experiment and subsequent repetitions, including Miller's, were designed to read only fractions of wavelength, completely ignoring the integer number of fringes. Dorks? You guys don't even know Earth's orbital velocity is right under your noses? You just gotta sniff a little harder.
Went unnoticed for 120 years.
And he came along with the nose for it, and he found the math that Maxwell was just missing. Maxwell and Faraday, no idea. Consequently, the amplitude observed in experiments is much lower than it should be, and the estimate of velocity from equation 20 is lower than it should. Yeah, okay. In a recent paper, so wait, let's just take a peek here. Solar velocity. He calls it solar velocity, but we're not dummies. We know it's Earth rotation. We know what Michelson, Gale, Pearson measured. We know what they measure at LIGO and Ginger. Those people aren't dumb. They know what they're measuring. So this isn't solar velocity, Mr. Múnera. It's called Earth rotation speed. And so let's just see here. Earth rotation speed at noon. 6 p.m. Wait, what? It's different. No, this guy must be wrong. He called it solar velocity, so we know that Earth doesn't rotate this differently, at this different of a speed at different times of the day.
Dude, it's solar velocity. It's differently throughout the day.
Yeah, that's much better, isn't it?
Yeah.
Don't you know about the fact that the elliptical orbit around the sun goes faster and slower throughout the period of one day?
Dude, it makes so much sense when you put it like that. I just never conceptualized the speed as being
you don't know enough about light.
A constant. Yeah.
You don't know about the math of light. So, consequently, the amplitude observed and experienced is much lower than it should be. The estimate of velocity from equation 20 is lower than it should. In recent papers, we've simulated the response of the Michelson-Morley interferometer, assuming the, what was his name again? Shug? We're just going to say Shug and the boys.
Oh yeah, Smootin' the boys.
Smoot the boys, thank you. Simulated response of the Michelson-Morley interferometer, assuming the Smoot the boys' solar velocity, when only fractions of the fringe are red. So he sure likes talking about Smoot the boys, doesn't he? We're gonna have to talk. You said we can discuss that after, right?
Oh yeah, I mean absolutely. It's the CMB lads.
Okay, cool. So I would just the CMB lads made an assertion about solar velocity.
First I'm hearing about it.
Okay, cool. When only fractions of fringe are red, the apparent fringe shift amplitude under the incorrect data gathering procedure only amounts to 3.2% of the amplitude that would be observed if the whole fringe were measured, thus explaining the consistently low values of laboratory velocity obtained in all Michelson-Morley type experiments. I wonder if at the exact same time that this guy was writing this paper, he was the same time that so this is page 10. All right, so this was what month? It's a bummer. If he had only met up with Ruyang Wang, Wang would have not made a fool of himself and filed for that patent measuring direct velocity using the classic Sagnac interpretation of reading fringe shifts. Huh.
I love that all of this happened before Wang, right? So like I can still swoop up these measurements and then have the actual first order ratio for the velocity component instead of the role play LARP.
Yeah, you're right.
So overall, this paper is still great, and it's an awesome trap for the heliocentrist enthusiast. So
yeah, the fact that like a heliocentrist actually tried to use this paper, I mean,
because they don't know what happened, bro. They have no idea about like the proportional relationship, that how it derives it, like how it was based off of Fresnel's thing and Fazal and all that. Like they like it's all a mystery to them. So like when they look at that relative motion of the Earth and ether, they're like, oh well, I guess that means that because they didn't get a 30-kilometer reading, that must be there's no ether. It's like, well, no, stationary ether, homie. The velocity component would only come from the fucking motion of the Earth, right? If the ether is stationary and the other thing is moving and you're trying to measure that movement, right? What did you fail to detect? The ether or the movement, right? It's very simple logic, but it's like just getting people to that is a whole hurdle because people don't understand the concept of the ether and how all motion would be relative to it, how they figured that out through light, blah, 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 right? But yeah, it's very straightforward when you see it. So like that's how these people get all wrapped up in this, and they're just like, oh yeah, it's definitely spinning, rotating at different velocities and stuff. Just can't feel it.
So 3.2% if the whole fringe shift were measured, thus explaining the consistently low values. Oh man, so loaded. Okay. So for completeness and fairness, we briefly review in this subsection the analysis of solar motion performed in the early experiments. In 1881, while at Helmholtz laboratory in Berlin, Michelson invented his interferometer and performed his first experiment. Regarding solar motion, he stated, "At this time of the year, in early April, the Earth's motion in its orbit coincides roughly in longitude with the estimated direction of the solar system, namely toward the constellation Hercules. The direction of this motion is inclined at an angle of about 26 degrees to the plane of the equator, and at this time of the year, the tangent of the Earth's motion in its orbit makes an angle of 23.5 degrees with the plane of the equator. Hence, why we may say the resultant would lie within 25 degrees of the equator. The nearer the two components are in magnitude to each other, the more nearly would their resultant coincide with the plane of the equator. In this case, if the apparatus be so placed that the arms point north and east at noon, the arm pointing east would coincide with the resultant motion, and the other would be at right angles. Therefrom, Michelson estimated the ensuing fringe shift." Let's go ahead and highlight that. So, and let's just do another quick little pause here, and let's just remind everybody. This is 1887. This is back before Einstein. This is back before physics turned into nonsense land, and they derived this math from reality, direct measurements of light and the way that light propagates. They looked at Fresnel drag. They looked at Fizeau's experiments. They looked at Arago's experiments. They looked at the way that light is the speed of light, quote unquote, is directly relational to inertial speeds. And so it's nothing fancy. There's no magic math needed there. It's simple. It's a Sagnac effect. It's C plus or minus V. Simple. Good game. It's over. That's all. So that's what they estimated the ensuing fringe shift from. So now, in the next section, what's the name of this section here? So let's hear Mr. Múnera's analysis now of why all those guys that measured something with, direct experiments, why what they measured right in front of their faces was wrong. I guess. I don't know what he's going to say here. So in the same paper, the solar motion of the 30 kilometers per second was included in Table 3 above as 1881. In the same paper, Michelson also considered the possibility that the motion of the sun is small compared to the Earth's motion and estimated the corresponding fringe shift. He considered both scenarios equally likely because he went on to take the mean of these two numbers as the most probable. It is noteworthy that Michelson did not consider the other logically possible alternative, that the speed of the Earth around the sun must be zero and there's no frickin' motion. No, he says that the speed of the sun.
Got me all excited.
But it's hilarious how that's literally the other logically possible alternative, but it's not even gonna get mentioned. So that's why, honestly, this is why you have to honestly think that maybe Múnera and Miller and Michelson, you maybe have to think that these guys were possibly geocentrists, because the fact that they can't even say the other actual logically possible alternative about geocentrism, which even has a kinematic equivalence, that is, I think, kind of revealing, right? I want to be published, so I can't even say the actual other logically possible alternative.
No, they don't want to. They can't have any record of it being equally as viable. It can only be viable as a kinematic position, through relativity. That's the way they want you to look at it.
But so you what I'm saying, even if these guys were geocentrists, maybe they just would never say it.
Oh, yeah. I mean,
because they want to be published.
You mean Múnera?
Possible.
Or Michelson?
Michelson, Múnera, Miller.
Nah, I don't think so.
I think it's possible. But then you look at, that's what makes someone like Robert Bennett so much more, I don't know, it's one reason I respect him, that's for sure. Because he actually published the papers and said it.
Yeah, you just admit what the readings give.
Yep. So perhaps the logically sensible alternative was not a physically possible alternative in Michelson's age. Or so the alternative being that the speed of the sun could be larger, much larger, than Earth's orbital velocity. In the 1887 Michelson-Morley experiment, for unknown reasons, emphasis was on orbital motion only. In what precedes, the orbital motion of the Earth is considered if this is combined with the motion of the solar system, concerning which but little is known with certainty. The result would have to be modified. Since this is the best known paper, most writers believe that in a Michelson-Morley experiment, orbital velocity is the only relevant motion. For instance, Lodge, for completeness, a null solar motion is entered in Table 3 as Michelson-Morley 1887. In the experiments carried out by Morley and Miller from 1902 to 1905, solar motion was assumed very much as Michelson did in 1881. The magnitude of terrestrial motion was about 33.5 kilometers per second, which resulted of a combination of the diurnal and annual motions of the Earth, together with the presumed motion of the solar system toward the constellation Hercules with a velocity of 19 kilometers per second. On the dates chosen for the observations, there were two times of the day when the resultant of these motions would lie in the plane of the interferometer, about 11:30 a.m. and 9 p.m. Miller did not notice that the solar motion used by Michelson-Miller and himself contained a significant weakness until 1925. This recognition was prompted by a detailed calculation of expected outcomes, very similar to our calculation in section 2.2. In his words, at the end of the year 1924, when a solution seemed impossible, a complete calculation of the expected results for each month of the year was made for the first time. Emphasis was added. Miller then understood that the well-known motion of the solar system towards the constellation Hercules, with a velocity of 19 kilometers per second, is only a relative motion of the sun with regard to the group of nearby stars, and it may give no information as to the motion of the group as a whole. Emphasis on the original. Then, for his large and final series of experiments during 1925 to 26, Miller introduced a new experimental design: continuous rotation of the interferometer day and night without assuming any azimuth for V1. The analysis of his results led him to obtain the two estimates of solar velocity named Miller 1, or labeled Miller 1 and Miller 2 in table 3 above. So, go back to table 3 here. Oh yeah, so back to those solar velocities. Yo, where the crap is your axis labeling, Mr. Múnera? Dude, what? Miller's experimental design introduced a new concept in the design elements that has not been duly emphasized. Continuous repetition of an experiment under constant conditions with respect to the laboratory for long periods of time. The goal is to uncover small effects that are missed by the conventional design. For instance, the effect of the velocity of Earth with respect to absolute space. To describe this class of experiments, we hereby propose a new word: Adialeiptometry, from the Greek words adialeiptometric and eutupov, meaning unceasing or...
Yo, is that a word or an equation, bro?
The old Utpov, meaning unceasing or continuous measurement. Unceasing or continuous measurement. Other examples of adialeiptometry are Buffo's daily observation of a Foucault pendulum during 8 years of the 40s to the 50s. Definitely going to check that out. 1,000 million% going to check that out.
Shout out to Buffo.
Elias' observation of a paraconical pendulum during several months, day and night during the 50s. Shout out Elias. Our ongoing research with paraconical pendulums and... Ooh, is that so? I didn't know he did pendy work.
Oh, dude, I can't wait to see what he did with the fucking pendulum after what he did with an interferometer.
Yeah. Neuropendy work. Okay, so 35 and 58. Let's check those out. Actually, let's check them out right now real quick. So, page 23. Years go up to 22. Shoot. What are they called again?
35 and 58.
35,
Or
58,
no.
sir.
Our ongoing research with pendulums.
Yeah, 35, 58, you're right. So 58, so this one. I was hoping to have Pendy in the name.
Me too.
Doesn't sound like Pendy work.
Yeah, it sounds like the opposite of a pendulum. He keeps talking about Michelson and Morley and Miller in each one of them.
Yeah, bro, get off it. Chill out on the Michelson-Morley. Let's just talk about pendies. All right, so anyways. Summarizing section 2, the Michelson-Morley experiment cannot be interpreted as a demonstration that the two-way speed of light is independent of the observer. Indeed, under the incorrect data gathering procedure used by Michelson-Morley and by Miller, the result was not null. If Michelson-Morley and Miller had used the correct procedure for measuring the total shift, integer fringes plus fraction of a fringe, duh.
Yeah, highlight. Do you remember when that guy accidentally steelmaned that a little too hard in a conversation?
Yeah. The correct procedure.
Yeah, emphasis on the correctness. Extra fucking pink.
Too purple, man.
Close enough.
The correct procedure for measuring the total shift, integer fringes plus a fraction of a fringe. So, if I was going to come up, if I was going to come up with a way to measure speed, let's just say I was going to use the wheels on a bus that go round and around, and I know that every time the wheel goes around, it goes, let's say 3 feet. So the wheels on the bus go around, and every time they go around, it goes around 3 feet. Well, what Múnera's going to tell me to do is to actually take that and take a fraction of that and then add so it's actually going to be like 300 something that's what Múnera wants me to do essentially. And then I'm going to make my speedometer built on that, and then I can tell the actual absolute velocity of the wheels on my bus.
With respect to sigma, yeah.
With respect to sigma, yes. Very important distinction. That allows them to stay kind of relativist, right? So,
sorry.
It's just like a little dog bone. Like, we're only talking about one frame, don't worry. So, they should have obtained a much larger amplitude and hence a much larger velocity of the laboratory. In addition, Michelson-Morley did not provide error analysis for their results. Oh, the old error analysis. Don't worry, Thomas Robertson can take care of that in a couple of years, buddy. Maybe you should, be on the lookout for those Fourier transforms. The missing statistical error bars are quite large and do not permit a negative conclusion, as Michelson-Morley did. Furthermore, the fact that there is one experiment, Miller's, that apparently contradicts the predictions of special theory relativity warrants, in our opinion, a repetition of the experiment using modern technology. Our Adialeiptometric experiment at CIF, Columbia something. This design of our experiment, from the foregoing discussion, one concludes that a correct design of a Michelson-Morley experiment should be based on the identification of a large number of fringe shifts during one rotation of the interferometer. A possible approach towards this end is to make many observations during one rotation, say every 1 degree. The experimenter should be reasonably certain that in passing from an arbitrary position of the interferometer to the next, say, phi, right? No. Theta. Thank you.
Yeah. Horizontal line is theta. Vertical is phi.
That's why I'm always getting them mixed up. Thank you. Okay, so theta, top of a T, horizontal. Of the interferometer to say theta plus 1 degree. The reference fringe has moved less than 1 fringe. Wait, what? The experimenter should be reasonably certain that in passing an arbitrary position, theta, the interferometer, the next, say theta plus 1 degree, the reference fringe has moved less than 1 fringe. Okay. In the few turns of the Michelson-Morley experiment, and in the many repetitions by Miller, measurements were made every 22.5 degrees, so that it was completely impossible to know how many fringes the reference fringe had moved. They rotated the interferometer from theta to theta plus 22.5 and observed that the reference fringe was at a different position and naively concluded that the fringe had moved through less than one fringe. Position and naively concluded that the fringe had moved through less than one fringe. Huh. In many famous repetitions of the experiment, like those by Kennedy and Illingworth, the situation was made even worse. The experimenter determined the initial position of the reference fringe and then rotated the apparatus through 90 degrees. Obviously, nobody knows how many fringes shifted past the fiducial marker during such a massive rotation of the apparatus. However, without hesitation and without evidence, all experimenters up to date have interpreted their reference fringe moved less than one wavelength. Dude, something tells me that Miller didn't just overlook that one and that he actually was aware of how many fringes changed between every, like... When you do it however many frickin' thousand times, you're going to pick up on things like that.
It's the most important part of getting the velocity component, so I don't understand how they wouldn't have done that.
Yeah.
It's how it's measured. You wouldn't go, okay, here's what we're going to do, boys. We need to measure the exact amount of fringe displacement during the rotation to get the velocity component, and then we're going to rotate it such that we can't tell from the reference point. Like, that's doesn't seem...
Yeah. So that just sounds like a weird, like, it's just like him wanting to have a qualm, I feel like. So, pardon me. So another weakness in the design of the original Michelson-Morley experiment is implicit in Miller's writings. These observations have involved the taking of over 200,000 readings of the positions of the interference fringes, requiring that the observer should walk in a small circle in the dark while making the readings at a distance of around about 160 miles. Sir Oliver Lodge, an acid critic of Miller, noted with irony that it is rather surprising that the readings were made by a peripatetic observer? Made by a peripatetic observer with the instrument in constant and not very slow rotation.
It was in constant slow rotation, though.
One would have thought that a stoppage of the frame and a reading of the fringes by a seated observer in many azimuths would have been more satisfactory. What? Dude, is he just, like, making crap up? Like...
Just attacking the way they took the measurements so that he could discredit the amount of fringes that they measured, so he could say that the fringe, that when you add up all the fringes correctly in his methodology, you could have all these, you could have as many velocities as you want.
But just saying that it's like, what, not a very slow rotation, like that's his qualm, like.
And it was. I can't remember what it is off the top of my head, but it's
yeah,
like,
but it's like he can get away with saying it. He can only get away with saying it because it's a subjective term, very slow.
Yeah, it's literally like a slow rotation. I forget. Like I said, I forget what it is off the top of my head, but it's literally not a fucking fast rotation.
Not something you're gonna measure, right? Oh, you can't measure motion with it, but you can when you rotate it really slow. If it's not slow enough.
Faster than you need, but slower than you like.
What, yo, Democ, 1 second.
What up?
What's up, dude?
So, our experimental design solves the two weaknesses noted in previous two paragraphs. A stationary interferometer performs a slow rotation at the Earth's angular speed and can be read by a seated observer, a video camera connected to a computer at short intervals of time. During the setup process, the first semester of 2002, we started with measurements every 15 minutes, which amount to rotations of the interferometer through 3.75 degrees. Dude, this is just more gaslighting. They love to gaslight Miller. Oh, we got a computers now. Sorry, Miller. The interference
Miller
pet-
didn't have a webcam with
Dude.
Wi-Fi hooked up to his monitoring station.
Right, dude.
Like, wow, that dude sucks.
Come on, Miller.
Dude, that's what
Fucking
this
Miller.
is. Interference pattern from one observation to the next showed differences that could be appreciated by the naked eye. We tried shorter interval times, finding that observations taken every 2 minutes appeared identical to the naked eye. Thus, the initial experiments in 2002. So, wait. They're identical to the naked eye, but you needed them. Just gaslighting. Good grief. So, you may not have had the webcam, Miller, but don't worry, you didn't need it. Thus, the initial experiments in 2002 were manually made at 2-minute intervals. Starting in 2003, we implemented an automatic system for data gathering and have used ever since 1-minute intervals. Oh, sorry, Miller. You don't have automation.
Dude got automated by ChatGPT, dog. Rest in peace.
Yeah, nowadays I do my experiment. I say... I voice chat to ChatGPT. I say, hey, can you do some kind of experiment or something? And then it does it for me. And then it gives me a paper. So, sorry, Monero, but I'm going to one-up you with that. So, in this way, we're reasonably certain that if the shift of the... Did I skip anything? Yeah, automatic system for data gathering. In this way, we are reasonably certain that if the shift of the reference fringe does exist, it is smaller than 1 wavelength. During 1 minute of the Earth rotates through 0.25 degrees, which means that the spatial resolution of our experiment is 22.5 divided by 0.25 equals 90 times better than the Michelson-Morley experiment. Gotcha. Okay.
So can we scroll up real quick? There's some highlights I wanted to pick out of that. Okay, so scroll up a little more. Okay, rotated the apparatus, fringes, okay, scroll down. Another weakness of the design. These observations involve taking over 200,000 readings, 160,000 launch. Critical Miller, the irony that is rather surprising that the pitted-to-dig observer of the instrument constant nut the azimuth would have been more satisfactory. Scroll down a little bit. But God, I can't remember what it was. There was something in there that I was like, oh, we need that. Our hesitation without evidence. The experiment states to the fringes. I can't remember. It's all good. Never mind. I'm sorry.
Oh, good.
I had to while we were on that section. I was like, now I'll come back to it, and now it's gone.
So, description of our experimental setup. As previously described in citation 58, a symmetric Michelson interferometer was mounted on top of a reinforced concrete anti-vibration table 4.48 meters long, 2.57 meters wide, 0.32 meters thick that weighs 13.5 metric tons. The height of the table relative to the floor is 0.77 meters. The table is placed inside a room with dark walls and polystyrene thermal insulation in the former windows. Oh, okay. Wonder what your walls are made of. Okay. Gotcha. Cool. In the ground floor of the CIF Institute.
Reinforced concrete.
Centro Internacional de Física. International Center of Physics. Housed at the campus of National University in Bogota, Colombia, located at not theta, but phi equals 74 degrees, right? Phi?
Yes, sir.
Phi equals 74 degrees minus 5 arc seconds west. Lambda equals 4 degrees.
That's a single one is minutes. 2 of them is seconds.
Thank you. 5 arc minutes west. Lambda equals 4 degrees minus 38 arc minutes north and 2,556 meters altitude above mean sea level. The light source is green. Lambda equals 532 nanometers. Produced by a ND YAG diode pumped laser. Model DPY 325 over 42 5011. Or 42511, or no, 425 II, my bad. Manufactured by the Atlas Germany, whose maximum power output is 200. I don't know.
200 milliwatts?
Milliwatts? Is that what that is?
Couldn't tell you. That's what I would guess.
That seems like a good guess. Yeah, I think you're right. Okay, so we'll roll with that. 200 milliwatts. The laser light. That's a really no. That can't be right. That'd be really low power laser.
Yeah,
Right? Or is that 2 watts? 200 milliwatts, 2 watts? If so, that makes sense then. Anyways, the laser light propagates along the east-west direction. The apparatus being located at the southwest corner of the interferometer on top of a metal supporting plane, 35 by 35 by 5 centimeters, fastened to the main concrete table. The laser's power supply is placed outside the anti-vibration table. The horizontal of the laser beam was checked with a precision level. The light beam splitter is a prism equivalent to the semi-transparent mirror in the original Michelson-Morley setup, located on top of another independent metallic supporting board, 88 by 88 by 5 centimeters, attached to the main concrete table. The mirrors are placed on top of small brass tables that are 10 by 10 centimeters with legs of adjustable height fastened directly to the concrete table and placed at the end of each arm. The length of each interferometer arm is given by the distance from the center of the beam splitter to the face of each the east and north mirror. L1 equals L2 equals 2.044 meters as measured with a metallic tape. The interference pattern is observed with a Sony video camera focused on a small frost glass screen, 6 by 4 centimeters, placed around 1 millimeter in front of the camera lens. The glass screen is 20 centimeters south from the beam splitter. The camera is oriented along the south-north direct. But let's read this real quick. A rigorous critic may note another possibility. The variations in the fringe shift may be so fast that they cannot be observed by the eye. The video camera, however, has a temporal resolution higher than the eye and did not show any instabilities in the interference pattern. Additionally, during 2005, we also took some series of observations every 15 seconds. Interference patterns were similar from one observation to the next, hence we say reasonably certain in our claim that fringe shifts between successive observations are smaller. Dude, what? This guy is such a freaking... Like, so, yet again, like, he criticized...
What color do you need to highlight that in?
Wow.
Like, what would express the level of emotion you feel right now?
It's
Color-wise?
just... Like, the only word is goober, man. It's the gooberiest goober move, especially for a guy that's like anti-Einstein kind of like. So he went on to like up there. He went on about all that crap about Miller not being able to tell the differences between his turns, and then right here he's just he's just saying like it doesn't matter. Like what a
The video camera, however, has a temporal resolution higher than the eye and did not show any instabilities in the interference pattern. Additionally, in 2005, we also took some series of observations every 15 seconds. The interference pattern were similar from one observation to the next. Hence, we stay reasonably certain that our claim that the fringe shifts between successive observations are smaller than one wavelength.
I mean, you get my objection, right? Like
No,
why?
what are you saying?
Because up here he's going on. Where was it? He talked about
Well, if you don't have your reference shift and you're not monitoring it the whole time, you can't
Yep,
get a
and then he
reading.
goes on to say it doesn't
Right.
matter.
We're having
go.
Different spot. Okay, so they rotated the interferometer. Sorry, I was looking at the bottom part. They rotated the interferometer from theta to theta 5 plus 22.5 degrees. They observed that the reference fringe was at an apparent position to naively... right. Had moved less than one fringe. Oh, so he's concluding they made the same measurement.
Like,
Gotcha.
So he's complaining about it there.
Right, gotcha. Okay, gotcha.
And then here
Yeah.
he's saying that they stay reasonably certain that it's smaller than so just basically saying it didn't matter.
Yep. Yeah, gotcha.
Just goober, man.
Can you, does that PDF highlighter can you draw like a line from that highlighted text to the top part so that we just never forget that?
I don't know if I can actually, but I could. No, I'll have to revisit it later.
Yeah, that's hilarious though. Yeah, so they probably didn't measure the same thing. Well, we measured the same thing. Nice.
Exactly. So there's that, and then he did that, and then he also did it with the with this.
Oh, the naked eye. Yeah. Okay. Can you see?
It's just like he gives these criticisms, and then he goes through and talks about how none of them matter.
How none of them mattered in the end. That's awesome, dude. Hell yeah. 11 pages into this bad boy. Dude's just refuting himself.
Yeah. So, I mean, at least, you know, he did his job. He muddied the waters enough to get people like Grayson to come give us this paper as if it's like a... as if it's saying anything. So, Figure 5 is a diagram of our experimental setup. So we've got green laser, red laser. Ooh, wait a minute. Dude, are you kidding me? You can just use 2 different colored lasers? Did those wave patterns interfere with each other?
Well, the color would be dependent upon the frequency of the light. So that
Yeah. So isn't it gonna just change, right?
yeah, I mean there would be a different.
It should be like a totally different color depending on the frequency shift.
Yeah, but there's a
Are
totally
they-
different waveform coming out. I mean,
Yeah, they
if they're
might be
using
able to
two lasers.
differentiate it.
Are they saying they use those at the same time or different times? So from my
Question two.
understanding, I thought they used them at different times.
Okay, that
but-
would...
No, because then it was continuously running.
Ooh, okay.
So
Well, I guess we can read and find out here, huh?
yeah, let's see what's going on here.
So, so we've got beam splitter, end mirrors, polarizer, frost glass.
I bet they know based on the difference in the frequency of the two different lasers. Like,
Yeah, they could
what
possibly-
its oscillation rate is supposed to be
Yep.
of the interference pattern. And then
Possible they
compare it to,
could
like,
pick it out, yeah. So only one laser is on at a given time. There we go. Simple.
Okay.
Simple. To decrease effects due to air motion, the optical trajectory is enclosed inside a plastic tubing, approximately 3 centimeters in diameter. To stabilize the air temperature, the tubing is surrounded by a polystyrene insulation. Okay, he seems to like the polystyrene. The beam splitter is also covered with thermal insulation fabricated on the same material. Wow, more polystyrene. The small table supporting the mirrors are also surrounded by, you guessed it, polystyrene insulation. Additionally, there is another layer of thermal insulating material mounted on wood. This second level of protection is intended to decrease effects due to vibration of the mirrors induced by sonic vibration of the air, i.e. to control noise from the street and from low-flying airplanes. Never even heard of that one, but that makes a lot of sense. Additionally, there are cloth curtains surrounding the main concrete table along the south and west sides to avoid noise vibrations from the main street. Wow. So crazy, man. That is about 100 outside the campus, about 100 meters away. So that was talking about Figure 5 here. Okay. So the camera is oriented along the south-north direction and is placed on the south border of the concrete table. So it's on the south part, pointed up. The video signal is sent by a 1-meter cable to a computer placed in the same room, but outside the concrete anti-vibration table. Figure 5 is a diagram of the experimental setup. Each end mirror has 2 screws for vertical and horizontal adjustment. They are used to obtain an interference pattern containing some 7 fringes. Each fringe has a width of 1 to 2 millimeters. The interference pattern is very stable and remains the same over weeks. The laser has a built-in stability control. A Occasionally, after being in operation for more than 30 hours, the laser entered into recalibration mode. Huh? The measurements were then ended and resumed with the laser back into stable mode. That's kind of interesting. Expected fringe shifts. The fringe shifts to be expected in our interferometer can be calculated from equation 17. To compare observations taken in different sessions, we follow the usual... Oh, this is interesting. Marinoff. Miller. Marinoff. Wait. Why is there periodicity measured by Marinoff?
Not aware of any. I haven't, in the Marinoff thing, I don't recall him posting like graphs or periodicity or anything like that.
No, me either.
So we would have to...
So we're on page 13. I'm going to pop down to the bottom here and just...
Yeah, see, we're Marinoff. So measurement
So
of
we
the
know that
laboratory's
one.
velocity. Yeah. Put an I at the... Yeah. Marinoff.
That's the only one.
Marinoff. Dang. So he's got gravy that we don't have. That's unfortunate. Because that would be interesting if he measured periodicity with a fucking washing machine and $500.
Right. Dude, well,
Poor man's fucking interferometer.
Well, you know what I will say? Is oh, that's not the same paper we have, dude. New measurement. So then we need measurement of the... I have seen this one. You might have this one in your library. I feel like we've looked at it before.
I'll check.
1980.
All right, I got... These are my... What was it called?
Measurement of the laboratory's absolute velocity.
Nope, I got the same ones you do. Yeah, we'll have to track that down.
Yeah, as soon as we're done here, we should check that out.
Yeah.
It's funny, I just real quick, just while this thought's in my head, like it's funny because in this paper he talks about like how he was running it all the time and got kicked, like his girlfriend kicked him out and his like neighbors kicked him out of his apartment complex and like everything. And when you're reading all that, it makes sense now if was because he was trying to measure periodicities.
Dude, he was running it all day. Dude, it's just in there whistling dog.
Dude, wait, so he was trying to use sunlight. So for a while there, he had it like in the window or some crap. He had it like sitting in the window with a washing machine motor running all day long, and then he moved it around.
Dude, well, not even just the washing machine. Those those cogs with holes would whistle.
Right.
And then you got to think too. You lived in a communist area, or so like the construction of those apartments were probably paper thin. So like literally the whole entire block probably heard him, dude.
Yeah, I'm excited to look at that other paper. Okay, so back to page 13. So. Yeah, I'm very interested. So, the prediction of fringe shifts, 4 scenarios of solar velocity, notice large variations, terms of serial time, despite the large difference in the shape of the curves and minima are concentrated in a small region. The variations in position are larger for large declinations of solar velocity. Oh, wait, Miller 1, Miller 2. That says Marinoff. So maybe he's just extrapolating from Marinoff's one measurement. That's possible, but it's also possible Marinoff was measuring periodicity. I'll have to look into that more. So, anyways, To compare observations taken in different sessions, we follow the usual procedure of comparing against an arbitrary reference value. That for the Michelson-Morley experiment was the reading at the initial position of the interferometer. Since our interferometer is stationary, let us take midnight as the reference position. So the relative fringe shift, delta F, is given by delta F equals that old thing, equation 21. As discussed in section 2, the shape of the curve, delta F, versus local time of day, T star, will depend on the actual value of solar velocity, which is unknown. Figure 6 shows the expected response of our interferometer for 4 scenarios of solar velocity in table. Wait, okay, so yeah. 4 scenarios of solar velocity in table 3, Miller 1, Miller 2, Marinoff, and what is the boys? I can't remember.
Schmoot and the boys.
Schmoot. Sorry, Schmoot. Don't come after me.
Dude, how you gonna disrespect
Don't at
Smooty?
me, Schmoot.
Your boy measured the CMB and some sort of velocity component associated with it. Give that man his proper respect, dude.
My bad, Smoot. For a given solar velocity, there are variations over the year. The shape of the curve may depict significant variations over the year, as in the case of Miller 1 and Miller 2, where the direction of the solar motion is more or less perpendicular to the equatorial plane. If solar motion is nearly parallel to the equatorial plane, as in Marinoff's and in Shook and the Boys scenarios, the shape of the curve remains constant over the year, with the position of the minima shifting according to civil time. However, as shown in Figure 7, the position of minima remains more or less stationary in sidereal time. The magnitude.
What? So the fluctuations are coinciding with rotational times as well, all within the same span of a day. That are like the fluctuations of the sidereal variance. Like, well, come on. Just admit it's stationary, and this is all the sidereal rotation.
The magnitude of solar velocity in the 4 scenarios is about the same, ranging from 200 to 390 kilometers per second. Just, big old range. That's nice. That's convenient. The expected amplitude of fringe shift shows a much larger variation. I mean, I guess you have to have a big old range like that because that's the crazy fluctuations they measure.
Sometimes you're moving with respect to the sun. Sometimes the sun's moving with respect to the center of the galaxy. Sometimes the galaxy's moving with respect to Smoot's cosmic microwave background. You never know when you're going to be parallel or perpendicular to those.
That's literally what that has to be, right? Like,
Yeah, it's funny when the real world's funnier than jokes.
Yeah, dude.
When your steel man's funnier than I could ever
That
imagine.
hit me so hard because, that's literally like the only way you can try and conceptualize it.
And keep in mind, this is breaking how you read the fringes to even do this.
That's insane, dude.
This is like a whole
200 to 390.
Dude, homie pioneered a whole new way to look at interferometry to get 200 to 390 kilometers out of these experiments.
Grayson, you sent us this paper?
Well, I don't think he sent it.
No, he didn't send it. He just brought it up. But Grayson brought it.
Yeah, he did bring it up. But yeah.
You might want to just rethink the next time you bring this one up. Unless you're going to try and defend this. I don't think you're trying to defend this. Something tells me.
It would be tough to defend against people who know. Right?
This is... next time someone brings... If someone were... No one's ever going to bring it up again. That's...
Yeah, I know, right? You know the last time I did it.
But if they do... You just be like, oh, yeah, so you think the Earth moves 200 kilometers per second sometimes and 390 sometimes. Just depends on what time of the year it is, huh? Okay, man.
Within civil time. Within civil time, bro.
Okay, dude. So the expected amplitude of fringe shift shows a much larger variation, which is of fractions of the wavelength in the case of Miller's estimates, to several fringes. In the other two scenarios, I really want to understand. Dude, this is... No. I can just... Dude, this is so crazy. Alright, so let's give this a second here. So, fringe shift delta F is given by delta F equals F T minus F midnight length over... What was lambda again?
I think that was their. Was it a latitude? I think. Oh no, the wavelength of light used.
Okay.
Show me the equation.
Right here.
Where's lambda?
Isn't that it there?
Oh yeah, sorry. Okay, so lambda. Yep. Yeah, L lambda. Beta superscript 2 subscript I cosine 2 gamma minus beta, same thing, midnight cosine 2 gamma midnight. As discussed in section 2, the shape of the curve of delta F versus local time of day will depend on the actual value of the solar velocity, which is unknown. Sick. Figure 6 shows the expected response of our interferometer for 4 scenarios of solar velocity in table 3, Miller 1, Miller 2, Marinov, and Smoot and the boys. For a given solar velocity, there is a variation over the year. The shape of the curve may depict significant variations over the year, as in the case of Miller 1 and Miller 2, where the direction of the solar motion is more or less perpendicular to the equatorial plane. If the solar motion is nearly parallel to the equatorial plane, as in Marinov and Smoot and the boys scenarios, the shape of the curve remains constant over the year. With a positive...
Oh, dude, that's so crazy.
With the position of a minima shifting according to civil time. Civil time. However, as shown in figure 7, the position of the minima remains more or less stationary in sidereal time. The magnitude of the solar velocity in 4 scenarios is about the same, ranging from 200 to 390 kilometers a second. The expected amplitude of the fringe shift shows a much larger variation. Okay, so that's where they're getting the periodicity, which is the fractions of the wavelengths in Miller's case, estimates to several fringes in the other 2 scenarios. These differences are caused, of course, by the different directions of solar motion, as argued elsewhere. Citation 36. We're going to have to cop that. The shape of the relative fringe shift curve delta F versus T star may be used to obtain solar velocity. Section 4 describes preliminary results of that exercise.
All right, let's hop down real quick and highlight 36.
Yeah, this was difference. Yeah, differences in the old solar motion. Oh, Múnera and analyzing his thing again. Cool.
Oh, I thought we were further up. My bad. Wait, where? We were on that page, weren't we?
We just get put in a black hole. Say no.
Oh, this is the page. This is the page because I wanted to grab that and then.
Yep.
All right, so here we are.
All right.
Want me to take back over?
3.4. Yeah, sure.
So the design and setup of the experiment was carried over the year 2002. As mentioned in 3.1, the interval of measurement was chosen during the first semester of 2002 to assure that the interference pattern is almost identical from one measurement to the next. During that period, we also... It's just so funny that you got to do that. During that period, we also checked for the possible existence of periodic vibrations in the concrete table and/or the video camera support. For this, we measured acceleration with an apparatus capable of discriminating 0.001 g. Measurements were performed at different times of the day, in particular during the evening rush hour from 5 to 10, from 5 to 8, when heavy trucks and low-flying airplanes can be heard passing by. Accelerations along two horizontal directions, west-east and north-south, and along a direction normal to concrete table were checked. Acceleration readings do not show periodic behavior, and the amplitude, I appreciate that. Because even Thomas Roberts can't admit that. The amplitude is at the noise level 0.001 g. The interference pattern itself is extremely sensitive to ambient noise. However, only about 5 readings were lost during several weeks of tests. The reason for the high success rate is that the concrete table returns to rest within a few seconds after entering in vibration by, say, the passage of a heavy truck. The only perturbing external influence that completely destroyed the interference pattern during intervals of 1 to 2 minutes was the operation of an air compressor in a nearby laboratory. This is most likely due to the excitation of the resonance modes in the damping system of the table. When the compressor was operating, we did not measure. Fortunately, the compressor was moved by the end of 2002 from that particular place. We used 2 thermal sensors to check the thermal stability of the air around the interferometer. One of them was located next to the beam splitter on top of the supporting table. One moment, please. Pardon me, sorry. The other one was located inside the laser beam enclosure, alternatively on the west, east, and north-south arms. Most of the time, temperature is constant, within plus or minus 0.2 degrees Celsius, sensor sensitivity. Occasionally, during a 24-hour run, there is one change of temperature, either of plus 0.4 degrees Celsius or minus 0.4 degrees Celsius. Humidity and illumination were also checked during the experimental sessions. Illumination is constant because the room is always dark, but humidity is variable and is more or less periodic, with variations associated with solar motion. Ooh, that's interesting. Okay. That's definitely something to be aware of.
What we got here? So humidity is variable and is more or less periodic, with variations associated with solar motion. Interesting. So illumination is constant because the room is always dark, but humidity is a variable and is more or less periodic.
Something to be aware of. Hence, the effect of humidity must be corrected from our data. And apparently they might do that in section 4. During the setup period, it was also noted that the most difficult time to perform stable measurements was about the peak of the evening rush hour from 6 to 7:30. To avoid that noisy environment during the week, it was decided to carry out observations during weekends and holidays, as indeed done during 2003. Analysis of data from 2003 did not show peculiarities in the Friday evening data when the interferometer started operation, so that by the end of 2004, we started collection of data also during weekdays. During October 2002, the temperature in the room housing the interferometer was continuously changed using 4 electrical oil heaters. A variation in the room air temperature over a couple of degrees Celsius produced a severe change in the shape of the interference patterns, which would make completely meaningless any experiment. Since November 2002, all measurements are made without any heating. To check whether the observed variations in the fringe shifts could possibly be ascribed to intrinsic periodic oscillations of the laser equipment, we installed an alternate. So that's why they had 2 lights. An alternative light source, a conventional helium neon laser manufactured by a Belgian company, also shown in Figure 5. Consecutive series of data were taken with the green laser and the red laser in the period November 2002 to October 2003. As reported elsewhere, the interference patterns were taken with both lasers exhibit the same cyclic behavior. Hence, the observed periodicities are not due to the intrinsic cycle variations of the light source. Go ahead and highlight that. After observing periodic behavior of the interference pattern during a whole year, both with the green and red lasers, it was also checked whether such behavior could be induced by periodic variations of the power supplied to the laser sources. Good job. Good on you. This was done in November 2003. But still, like, okay, so that's good on you, and you should do that, but the reason that no one even bothers with this stuff, right, is because you wouldn't get 30% variation. Like, so maybe you could rule out the daily periodic variations with that. Maybe you can make an argument for that, but I don't know. So this was done in November 2003. Large variations of voltage were imposed to the laser apparatuses that did not produce proportional effects on the interference patterns. Hence, it may be concluded that the periodic oscillations in the fringe shift are not due to daily voltage drops during the hours of high electricity consumption. I mean, it's also just kind of follows with logic, right? It's still measuring the speed of light regardless, so... or quote-unquote speed of light. The analysis of the 2003 data suggests that some instability in the laser apparatus during several hours immediately after turning the laser on. Hence, from mid-2004, it was decided to use the green laser only, without ever turning it off after the experimental session. Wow. Okay. Data, recollection, and raw data. A video camera permanently observes the image of the interference pattern on the frost glass screen in Figure 5. Figure 5.
I think it might be at the bottom. Or no, wait, it's up. It's where it shows the two lasers or whatever when we were trying to figure it out ahead of time.
Oh, yeah, Figure 5.
There.
Old Figure 5. My bad.
Dude, I bet you could Control FIG 5 or something.
Yeah.
FIG period 5, and it'll be like, oh, right here, Toby. Got you, Broody. Yep. Nice. Figure 5. So, yeah.
I mean, now that I know what it was I was looking for, I didn't really care anymore.
I got you.
So, where's old Figure 5? There we go. This color image is captured every minute and stored in the computer using software developed by Owaha Group of the Department of Systems Engineering of National University. Really? Just to take pictures? Wow, it's a real complicated software. For a total of 1440 images produced each day. Since each experimental session lasts several days, several thousand images in TIFF format, about 300K each, are collected in each run. Each image is labeled with the date and civil time at the moment that the image was stored. Although the whole image is not required for our data reduction, we are keeping them as evidence of our work and for possible future reanalysis. Oh yeah, maybe in 100 years someone can come along and do a Fourier transform on it, and only grab the ones where you were like testing for your, like when you were doing tests of the temperature or some crap.
Hey, but you know what though? Respect though for keeping the physical copies, because
actually, like for real,
we know that there's a history of photographic plates and reference plates going missing.
Yeah.
You just have to trust our analysis. So
yeah,
shout out to the lad for at least backing it up for the boys.
Yep, for real. And actually, I wonder if we can get a hold of those.
I mean,
I bet we can.
Yeah.
306 CD-ROMs. Maybe they can mail us 306 CD-ROMs.
Yeah.
So yeah.
Imagine storing something on a CD-ROM, bro.
Well, it was 2000.
Was this done in the 2000? Oh yeah.
It was 2005. So there you go, man.
Yeah, still kind of disgusting.
Now we get to gaslight him.
Yeah, dude. Oh,
Dude,
wow,
I
we
hate to
didn't
say
have
it, but if you're storing your Fringe-Shifts on CD-ROMs, might be you got a
Funny.
problem there. I don't think those CD-ROMs are very good, very high fidelity of ones and zeros. So in the period 14th of December 2002 to the 2018 and October that's 2003. Wait, what? What is that?
Let's see. What? Typo.
Okay.
Or, well, wait, hold on. In the period of 14 December 2002 to 2018, October. What?
Yeah,
Oh, no.
right.
It's, no. Okay. It's
18th
December.
October. I see.
Yep.
Okay. This is a European dating, I think. Okay.
Yeah, it's just a typo. There's a ton in this.
Well,
like
they
little,
do it differently,
pairs.
different depending where you are in the world too. So it's just like my brain doesn't look at it like that.
Yeah.
So
There's
we
not supposed
took.
to be a hyphen there, so.
Yeah,
supposed to be a
well, it's
space.
from this to
Mhm.
this.
Yeah. Yep.
We took 30 runs with the green laser and 16 runs with the red laser. After being convinced that the periodicities were not instrumental artifacts, we decided to use only one laser. The green laser apparatus was exclusively used from October 2003 to June 2005. About 60 experimental runs were carried along this period, of which 41 series correspond to the year 2004. During the year 2005, several runs of more than 10 days were taken. Wait, I thought this paper was published in 2006. My bad.
Yeah, so this is like the summation.
Okay. During the year 2005, several runs for more than 10 days were taken. The laser was continuously powered from October 2004 to June 2005. When it entered a recalibration mode that did not reset itself, observations were stopped at that time. Okay. Since the 13th of January 2003 onwards, during each experimental run, we also registered temperature, humidity, and light intensity at the end of each arm using small sensors manufactured by hobos in the USA. The sensors are located inside the wooden box enclosing the end mirrors. Temperature inside the eastern mirror enclosure varies at most 0.2 degrees Celsius during a weekend, but sorry, I'm just glancing at this. But temperature variations inside the northern mirror enclosure are somewhat larger. This effect is most likely due to variations in temperature outside the building, which are very large in Bogota, that are communicated through a former window covered with polystyrene that is close to the end of the interferometer. Temperature of the concrete table immediately below the optical path of the west-east arm is also recorded. Its value is constant almost all time. Table 5 shows the coefficients of the correlation between temperature T and relative humidity H at the eastern and northern mirrors. For 10 typical series during 2004, one per month, the actual dates for each series is in Figure 10. As expected, humidity is highly correlated, but temperature is not, due to the influence of external ambient temperature through the former window near the northern mirror. The zero correlation between mirror temperature and table temperature is produced by a completely constant temperature of the concrete table during the whole. Oh, that's why. I guess that's one reason to use concrete. The average values in last line of Table 5 were calculated for all 41 series taking after 2004. Man, it's actually it makes a lot of sense. Use a big old slab of concrete and you got a pretty stable temperature coming off of that. After collecting the images,
I always wondered why, like the Michelson-Morley experiment, for example, they had a huge slab of concrete.
Huge slab of concrete. You get low vibration and it's a stable temperature too.
Yeah, okay. It makes a lot more sense. I was like, that's a huge slab of concrete for some reason, lads. What are we doing here?
yeah. It's always like, oh, that's what they're doing. Okay. They really wanted to make it official, man.
You know what they say? The thicker the slab, the better the periodicity.
The thicker the slab, the thicker the periodicity. After collecting the images, the next step is to obtain the position of a fringe as function of time. This is done offline using a computer program written by one of us, which Miller never could have done. A digital profile of each image is obtained across a thin two-dimensional window placed upon the image. The position in pixels of this window is the same during a given run. The light intensity in the image is converted to a scale between 0 to 255. In the digital profile, a minimum value is a dark fringe. Dark fringe. Sorry, I'm just making sure I understand what I'm reading.
Yeah, the intensity value is 0 and dark to bright. So the darkness would be the gap in the fringes.
Okay, so yeah, they're just describing.
So the dark fringe would be the gap.
Ah, thank you, sir. While a maximum value corresponds to a bright fringe. Our analysis is based on the position of dark fringes in the image taken at local time t star. The position of a certain dark fringe is followed in all consecutive images taken during a given run. This process immediately produces fringe position in pixels versus local civil time. To increase the robustness of our measurement, we calculated the average fringe shift of 2 or 3 consecutive fringes in each image relative to the first image in a run. The average fringe shift versus local civil time obtained by the computer program without direct human intervention constitutes the empirical output from an observational run. Figure 8 is a typical example of a run with the green laser during the period from the 2nd to the 8th of September in 2003. The periodical behavior of the fringe shifts is evident and is similar to the expected curve shown in Figure 6. Figure 8 is labeled raw data, in a sense that no corrections have been applied to the data so far. The input to our analysis, which strictly is the raw data, is formed by the images of the interference patterns. So you just do an old school style, where you actually take a measurement.
Keep it OS.
Okay.
Is that a bunch of periodicity I see in there?
Yes. That's what Galev would call the space effect.
Oh, shout out to Galev.
Hell yeah! Shout outs.
Yo, you're wild, Mark.
Fucking right. Shout outs. God, what kind of show would we be without shout outs?
Shout outs.
Shout out to giving shout out.
Yeah. Shout outs on the shout outs, baby.
So there's the periodicity. There's the first order periodicity measurements, and then there's the correction for humidity and pressure. I don't know, man. Is it really that big of a deal that the Earth rotates faster and slower throughout the day? Is that really a big deal?
It's just a few thousand. What's a few thousand kilomiles between
With
friends?
little dynamic scaling between friends.
He said, "Is that big of a deal? I don't know. Balance some rocks, and we'll take a peek." Like, what the fuck?
So, environmental effects. As noted in section 3.4, environmental humidity of air varies periodically according to the daily variation of Earth, and the magnitude of fringe shift also varies in a similar manner. If the variation in the fringe shifts is caused by the humidity variations, then the humidity effect and any other causative periodical effect must be subtracted from the quote-unquote raw data curve. However, it may happen that humidity and fringe shift are not causally related, and that the correlation may be due to the existence of a common cause. Ha! Dude. Beautifully said.
Yeah,
I gotta give this guy some credit for that one. That's I like that.
Quote.
Where you at?
In that case, a subtraction of the humidity component would amount to elimination of the effect we are searching for. Another good point.
Dissipation. Yeah.
Finally, it may happen that a part of the fringe shift variation is caused by environmental effects and the remaining variation by the common cause directly. Another possibility. This is good stuff. In that case, a stochastic correction totally eliminating the correlation between fringe shift and the environmental variables amounts to an overcorrection, leading to a residual curve whose amplitude is smaller than it should be. Influence of ambient temperature and pressure upon the index of refraction of air was already known to Michelson, who corrected for such effect in his measurements of the speed of light, but did not consider them in the interference experiments. With regard to with regard to the index of refraction, Michelson's decision was correct. Indeed, using a modern semi-empirical equation, we have estimated the effect of variations of temperature, pressure, and humidity upon our interferometer. To find that the fringe shifts induced by changes in the index of refraction are much lower than the resolution of our equipment. I want blue.
Oh, whoa. Wait a minute.
Yeah,
Did
dude,
he-
you can't tell anything. It's
yeah,
not.
did he just undermine his whole humidity argument?
Yeah, he certainly did.
Hell yeah, brother.
Well, what do you mean? I mean, I
He
think
estimated that the effect of the variations of the temperatures and pressures of humidity upon our interferometer. Oh, okay, I misread. Wait.
Well, I mean, I think he's being legit about it. I think, like, you look at what he did right here, right? And he's taking what he's talking about right here. He's making sure to be like real careful about it. He doesn't want to even like rule out the I think he's doing it properly. I'm wondering.
I think you have to do double speak to get it to pass the peer review. Like you have to say.
I don't think it's double speak, because I think what he's saying essentially is that we've estimated the effect of variations of temperature, pressure, and humidity on parameters to find that fringe shifts are much lower. Induced by changes in the index of refraction are much lower than the resolution. Yeah, so it's just he's kind of saying, well, you're right. He did it. You're right. He did.
Yeah, but not like in a crazy. I'm just saying he's like saying we've got this reading, but then again, I'm going to tell you that the thing that's happening is such a low thing that even our reading isn't actually sufficient enough to keep track of it, because they're going to tell you, well, the Earth is moving, but it's moving at such a fucking rate because of the size and scale, and they just add these word after word salad, and then at the end of it they say so big, and then it's moving fast, but you can't tell. You can't fucking read it.
All he's really
kinda
saying here
close,
is with
but-
regards to this periodicity, and he's saying that he listed a few things here. He said that one, the actual periodicity that's measured and the humidity fluctuation that's being measured, he thinks that the humidity fluctuation could be caused by the same thing that causes the periodicity, but then he also is acknowledging that the humidity itself also has an effect on the periodicity. So he's taking all of that into account when he's calculating out the effects from humidity. He's making sure to not totally discount the periodicity in the math to do that. But then he does kind of undermine himself a little bit, because if this is the correction you have to make, then why would you even say this?
Right.
There's
that's
slightly
what,
unknown variables too.
Just a sec, Mark. Yeah, that's what threw me off too, because then he's just like, he just gives up the humidity. He's just like, well, it wouldn't even be discernible to.
Well, I don't
account
know if
for
he's
it.
saying.
Is that what
Not necessarily the humidity itself. I think the whole and like there's a couple unknowns that he has to take into, like that you can say, you can imagine, you can think about. But if you're not really sure if it's this, that, or this, and there's three different variances or like ways it can happen, then it's like still an unknown but known. You know what I mean? Like,
well, so here's what I think's going on. Right, he's just saying that you can still find the fringe shifts induced by the changes, or he's saying they still have enough resolution to measure the periodicity even if you have the changes of the refraction. I think that's what he's saying.
he's just trying to be hyper specific, I think, super specific about it. That way,
changes in it are much lower than the resolution of our experiment. Let's see. We have estimated that the effect of the variations of temperature, pressure, and humidity upon our interferometer. Okay, that's where they estimated it. And then to find the fringe shifts induced by the changes in the refractive index are much lower than the resolution. So,
Basically, like at that distance, or like just
okay.
whatever.
The influence of the ambient air. Okay, the influence of the ambient temperature and pressure upon the index of refraction. All right, we're just talking about the refraction index of air. Not okay. So slightly different in combination with the humidity thing. So he's talking about the refractive index of air itself, not okay. Makes
Well,
more
the
sense now.
humidity, that's what the humidity affects. Is the refractive index of air.
Yeah, the moisture in the air and
that's how it would affect the interference pattern, the periodicity.
Right, but he's saying that the refractive index, like the way that they treat that, it doesn't. It's the effects of that are lower than the resolution of their experiment. So,
well, you can see it in his image, right? So, even though there is a discernible, or what appears might be a discernible difference from humidity, you can still see the periodicity in it.
There's a difference from distance.
So even though that's there, it's lower than the resolution of our experiment.
Gotcha. Okay, yeah, gotcha. I'm for some reason I'm reading it wrong. That way you just
Yeah, no, it tripped me up too. So I'm glad we went over it.
There.
It's like not being able to resolve like something really small in the
Nah, he
foreground.
resolved it though.
Right.
Resolved it right there.
Yep.
So go ahead and highlight that. So ambient temperature was mentioned by Michelson as a significant source of experimental error in his 1881 experiment, was ignored in 1887 in Michelson-Morley. In his analysis of Michelson-Morley, Hicks suggested that the monotonic drift of fringe shifts was due to a thermal effect. Miller recognized the importance of temperature and built apparatuses in different materials, hence with the different coefficients of thermal expansion. Additionally, Miller tried to control for temperature variations and checked whether it was possible to obtain periodical effects on the fringe shifts from different variations in the interferometer room. Citation 22. In a reanalysis of Miller's work, Shanklin and collaborators attributed Miller's periodical fringe shifts to periodical thermal variations. Even the recent Stanford experiment carried out at a temperature close to absolute zero with an extremely tight control on temperature variation within 10 to the negative 5 K, according to the authors of Citation 63, attributed the observed periodical frequency shifts to mechanical effects induced by the temperature. However, although the influence of temperature is usually recognized, no effort is done to eliminate such temperature effect during the data reduction process. Wow. Citation 63. Did you look at that, Alan?
Yeah.
We're on page 16.
60 thrice. Oh, is that a different Wang? A new limit of signals on Lorentz violation and electrodynamics.
Yeah, we're definitely going to have to check that one out, too. We had a lot of stuff to check out from this one. So, as mentioned above, variation of refraction along the optical path produces a negligible fringe shift, so that the most important effect of temperature is thermal expansion and contraction of the interferometer, thus changing the values of L1 and L2. To decrease the variations in optical length, our experiment is set upon a concrete table that has a low coefficient of thermal expansion. However, the supports for the mirrors, which are fixed directly to the concrete, are fabricated in brass, so that thermal effects due to expansion of the metallic parts must be expected. Theoretical calculation of such expansion would require a detailed knowledge of the distribution of temperature, which is not available. In view of such difficulties during the analysis of the data taken during 2003, it was decided to implement a stochastic correction for the effect of the three environmental parameters: relative humidity H, pressure P, and temperature T. The correction between fringe shift F and each parameter is found for each series. A linear regression is then obtained from F and, say, H. This gives the maximum value of fringe shift that could be attributed to the environmental variable h. If this value is subtracted from the raw data, a corrected fringe shift f star is obtained that is not correlated any longer to h. The same procedure is now applied to the two environmental variables p and t, using in each case the most recently corrected f star. Due to limitations in the storage of data and the sensors, h and t are taken at intervals that vary from 1 to 5 minutes, depending upon the duration of the run. The correction calculated in previous paragraph is thus applied to the average fringe shift during the appropriate interval. For pressure, we did not have a microbarometer for the required accuracy. During 2002 or 2003, we used for the stochastic correction the data collected hourly at the El Dorado National Airport, 15 kilometers away from the National University campus, so that the pressure correction we had to average the fringe shifts over 1 hour periods, thus decreasing the temporal resolution. For the analysis in the present paper, we rather use synthetic monthly pressure curves derived from 20-year averages taken at a meteorological station on the campus of National University. In this way, the averaging of fringe shifts is done over equal intervals of the three parameters of H, P, and T. The largest corrections are produced by H and P after correcting for was pressure and humidity. After correcting for humidity and pressure in that order, the curve F star has a low fringe shift. The fringe shift has a low correlation with humidity, shown in the second column of Table 6, with no correlation with pressure. But the correlation with T is still large, which is temperature, as shown in the third column of Table 6. Third column of Table 6. After applying the correction for temperature, its correlation with T disappears. But the correlations with H and P slightly increase, as shown in columns 4 and 5 of Table 6. The averages shown in the last row of the table are calculated over the 41 runs taken in 2004. We also explored the application of the corrections in a different order, say pressure, humidity, temperature. The residual correlations are somewhat larger but still very low. The lower graph in Figure 8 is a typical example of the residual curve after correction for humidity and pressure. Note that although the amplitude is decreased, the periodicity is enhanced for the correction process. However, the amplitude of the final residual curve amounts to several fringes. As shown in last column of Table 6, the final curves have a low correlation to the environmental variables, which means that the procedure used here for eliminating environmental effects was successful. However, as implicitly noted at the beginning of this section, in recalling that variations of the index of refraction cannot explain the large observed fringe shifts, there remains a fundamental question. What is the physical mechanism that may explain the large effect of humidity and pressure upon fringe shift? For this reason, in the following, we show both the corrected curves and the raw curves. Huh, interesting. Okay. From the 41 experimental runs during 2004, we have selected a long run, several days, about the middle of each run as typical of that particular month. The dates of the runs are indicated in Table 7. Let's look at Table 7 real quick. Table 6. Corrections for H, P, and T. Oh, wait. Correlations.
Correlation coefficients.
Series corrected with H and P, and then final series corrected with H, P, and T. Then Figure 7. Amplitudes of the fringe shift curves in the year 2004. Average of fringes corrected, partial average, calculated and calculated. Gotcha. Cool. You're a nerd, Múnera. All right, so in a good way. Six. So yeah, 41 runs during 2004. Days. Table 7. Okay. Middle of each month is typical of a particular month. The dates of the runs are indicated in Table 7 and Figure 10. Each run is divided into 24 sidereal hour periods, and the fringe shift at each midnight is taken as a reference for that particular day. This means that the relative fringe shift at midnight is always 0. The relative fringe shifts at other times of the day are averaged over the several days in the run. Figure 9 shows the average fringe shift curve for the month of April, corrected for H and T as measured in the eastern mirror, compared in the same graph to the curves corrected with the data taken at the northern mirror. Both corrected curves have the same general shape, thus hinting to an underlying physical process that cannot be removed by the environmental correction. As seen in Table 5, Series 4, temperature at the northern mirror was not correlated in April to temperature measured at the eastern mirror. The right-hand side of Figure 9 shows the same curves for the month of October 2004, Series 8 and Table 5. Once again, the temperatures at the eastern and northern mirrors are not correlated. While the corrected curves are quite similar, thus hinting again to the existence of an underlying physical mechanism different from the mere environmental variations. The ones... I'm going to highlight that. The 1 sigma statistical error bands are also shown in the figure. And then, yeah, like this would go in line with, our understanding of the Elias effect too. Like all the crazy pressure fluctuation stuff that happens and the fact that everything is related to the periodicity of the sun and the moon. Yeah. Since the shapes of the corrected curves are similar using values of humidity and temperature measured at either the eastern or northern mirror, in the following we concentrate on the curves of the corrections based on the eastern mirror. Figure 10 shows the corrected curves with the 10 months analyzed in 2004 with the 1 sigma error bands. The error only contains the statistical variation over the several days that form the series. Other experimental and or data reduction errors are not included. For instance, the error arising from the fact that pressure correction was based on a synthetic curve rather than on observed pressures. Note that the error band contracts at some points. The amplitude of the residual curves is of several fringes, while the position of the minima varies over the year. Someone else want to read for a second?
I got you, Brody. Where are we at? Variations over the year. All right. Some of the sessions are identified by the date followed by the letters I, N, V. Some explanation is required. When the fringes move right or up, depending upon the interference pattern, the computer program arbitrarily defines the sense of an increase of the position of the fringe curve. However, it could be a decrease in position. This is due to the orientation of the reflecting mirrors that are modified during the process of calibration of the interferometer. The empirical curves may be plotted with the sign as signed by a computer or with the opposite sign. The latter produces the inversion curves denoted by the letters I and V. The curves, direct or invert, were selected for consistency for the theoretical expectations. Solar velocities consistent with observations. We turn now to a preliminary analysis of possible solar velocities consistent with empirical observations. The main features of these fringe curves are positions of two minima in terms of an angle sigma in degrees. The amplitude A in fringes is understood as the difference between the maximum and minimum values of the curve. Table 7 shows the amplitudes of the original and corrected curves. The latter information is contained in Figure 10. The general environmental corrections decreased the amplitude for the fringe curve. the most interesting feature of the corrected curves in the variation of the amplitude during the year. During the 4 months from July to October 2004, the amplitude is much smaller than in the rest of the year, which is, of course, confirmed by the partial averages shown in Table 7.
Whoa.
At first sight,
Did I read that? Am I understanding that properly?
see, the
Yeah.
most interesting, so during the first 4 months from July to October, the amplitude is much smaller than the rest of the year. So less periodicity fluctuations.
Oh, okay.
Which
Yeah,
is
yeah,
a-
yeah. That's
which is
crazy.
which is of course confirmed by the partial averages shown in Table 7. At first sight, the empirical observation is counterintuitive. However, some reflections indicate that this result must be induced by the direction of solar motion. By direct numerical calculation in a simple computer program
Oh,
written in
Shane.
Excel. Shane, we
Shane's
we gotta
getting
call in the
pumped.
expert.
Oh,
By numerical calculation, a simple computer program written in Excel.
well, I can do it.
Yep. It is found that when the right ascension of the solar motion is at a range of 170 degrees to 190 degrees, the observed ordering of amplitudes is reduced. When the right ascension is outside of this range, the ordering of the amplitudes is completely different. For instance, amplitudes during July and October may be the highest. The second half of October shows the amplitudes calculated for the solar velocities, namely V1 equals 350 kilometers a second, sigma degree. Yeah, okay. And then so that's the angles of ascension or whatever. So to get the direction of motion, as expected, the value of the amplitude of the fringes is directly linked to the value of the solar speed. So I forget what it is. What is it? It's the sun with respect to the center of the galaxy is like 270, 300 kilometers a second. So you're saying that the what was it, the amplitude? So the periodicity within July and October, right? He shows fluctuations that when he does his integral summation fractal adding, he gets those galactic velocities. Very cool.
Cool.
Scroll down, please. The fringe shift curve calculated with V2 are shown in Figure 10. It may be seen that there is a reasonable agreement with observation with the theoretical curves within 1 sigma airband in most cases. Ooh. I'm more of a 4 or 5 sigma confidence man myself, but 1 sigma is not too bad. From the previous qualitative analysis, it may be said that the solar motion consistent with our observations may be within a range of 300 to 360 kilometers a second, with the right ascension from 170 degrees to 190 and the declination between minus 45 degrees and minus 55 degrees. No additional qualitative analysis is presented at this stage. This matter will be pursued together with an analysis of data taken during 2005 that we are currently advancing. Closing remarks. Following Miller's pioneering efforts to have carried out the Adialeiptometric experiment using a stationary Michelson-Morley interferometer at our CFI laboratory in Bogota, Colombia for almost 2 years from the end of 2003 to June 2005, the present paper reports that the results from 2004 the present paper reports the results for the year 2004. After correcting for environmental variables, we have identified large fringe shifts whose period most likely is a sidereal day. To provide a context for this new experimental result presented in this paper, we start by discussing the meaning of the speed of light at the time of Einstein, and presented next the evidence then available for its constancy. It was argued that the evidence provided by the original Michelson-Morley experiment and its various repetition is not as strong as usually believed, thus justifying our new experiment where we tried to correct for the main weakness uncovered. The fringe curves observed in Bogota are consistent with the predicted curves using a constant speed of light in a preferred frame that adds vectorially to the laboratory velocity using Galilean velocity addition. From the qualitative analysis performed so far, it may be said that the solar motion that explains our observation is in the range of 300 to 260 kilometers, with the right declination of the celestial thing to get the direction of motion to be in line with the sidereal time. This value is similar to the other estimations of the solar velocity. Recall to Table 3. For instance, Smoot and the boys found that the solar speed is the same as what we're presenting, well, pretty close, and the direction of the declination is, that was it, alpha 165 degrees plus or minus 9 degrees, delta plus 6 degrees plus or minus 10, while Marinov obtained 303 with the kilometers a second with an alpha of 214 degrees plus or minus 5 and delta minus 23 plus or minus 4 degrees. Declination is the controlling factor for the relative depth of the two minima fringe curves. The value consistent with our curve seems to point towards the southern celestial pole, as Miller's observation seems larger than the value of either Smoot and the boys or Marinov. Finally, it is noted that in a recent experiment by the Stanford group, we'll have to hit that up. Oh, dude,
I think we already highlighted that one.
Interferometer. No, I don't know. We definitely
63. I'm pretty sure we got.
Okay, yeah, because I've got a backlog of vertical interferometer stuff I got to look at. Okay, so Stanford Group 63 amounts to the vertical interferometers, as they already pointed out elsewhere in 58. The Stanford curves are very similar to our own wall curves. For instance, Figure 8, but they were interpreted as caused by thermal effects. Oh no, dang it!
Whoops.
It should be noted that the Stanford Group tried to interpret without success the variation of the parameters.
Water
variations. Yeah. The variations of their parameters in the terms of the annual orbital motion of Earth in this section, as noted in Section 4, and can be gathered from Figures 10. The shape of the fringes curves does not follow a simple sequence. Then, if a curve is fitted to each month fringe shift curve, as done by the Stanford Group, the parameters of the fitting curve do not follow a simple pattern incorrectly expected in the paper.
So let's make sure we got 63 highlighted here. We do, yeah.
Oh, sweet.
So cool. Wow. So we just did a 3.5 hour banger there. Been a while since we've gone that hard on a paper. Well, actually, that's not true. It's only been 4 weeks? 3-4 weeks.
What's
It's
that?
a 3 or 4 hour bank.
Oh. Well, on that note, I guess we can close streams out.
Yeah, go ahead and wrap it up. All right. Good night. Thanks for coming out. See you on the next one. Peace.
Thanks for listening.